Okay, so I think there's no more people connecting now, so I think we can start. So Josep, please.
Sure. Okay, thank you very much, Julien. So welcome everybody to this fourth workshop of the PIXIL series of workshops devoted to the application of, let's say, subsurface imaging technologies to geothermal energy. So this workshop has been hosted principally by Julien Diaz, although there's a list of, let's say, of conveners here. So I thank you very much, Julien, for setting this up and gathering all of us together today. So today's workshop is called Present and Future of Geothermal Energy in Spain and France. And I am giving this presentation as coordinator of the PIXIL project, which is the sponsor of today's activity. And my idea would be to give you an overview of what the project is about. So if you have, let's say, already seen this, let's say, the project outcome, let's say, from previous workshops, you will not see many new things, let's say, today. But for those which don't know or are not so familiar with the PIXIL project, I think it's a good idea to quickly recap what we have been doing in the last 2 years. Okay. So first and foremost, this is an R&D project which has the following goals. So on one hand, what we aimed for 2 years ago when the project started was establishing a transnational network that improves geothermal exploration by means of R&D. Okay. By that, or the idea behind this is that we have several, let's say, groups of R&D that perform, let's say, in different fields of geophysical exploration in the area which is funded by this POCTEFA feather-based European funds. So in this case, we are talking about INRIA, Pôle Avenia, RTS, BCAM, University of Barcelona, and BSc. Okay, all of them in the fundable region. Okay. So these centers have or are excellent, let's say, in several aspects, but mainly in everything related to geophysics, mathematics, computation, okay, and how those technologies, let's say, can intertwine to obtain better, let's say, quantifiable information about the subsurface, okay, with the hope of improving geothermal energy exploitation in the region, okay. As overall, let's say, or as a major goals, I mean, there are several, let's say, transversal requirements for this kind of projects. One of them, of course, is sustainability in this Interreg VA region, which is the zone which you see here in orange in the figure. Also, we have, of course, transversal goals related to improving equality and, let's say, improving also concerns about climate change, neutral CO2, and so on. So funding again comes from FEDER funds. It's about 1.3 million, split about 60% in Spain, 40% in France. And this was originally a 2-year project. We are already running late, so we should have finished already, but we have asked for an extension, and we will be still performing activities such as the one that we're having today until April this year. So these are the partners that conform the project. So BSc is coordinating the activities, and we have again University of Barcelona, INRIA, BCAM, Avenia, and Realtimeseismiccan. So as you can see, we have let's say partners from purely academical let's say endeavors. We have fully private companies, and we have institutions which, let's say, lie in between or help in associating or in providing services, let's say, to the geophysical or geothermal community. Okay. Now, besides the partners which received funding and carry out most of the actual activities, let's say, associated to the project, we have a set of associated partners, okay, or what we call often the industry and user board. Okay. Originally, the associate partners are NGO, Quality Geothermia, and ALB. So these three have been, let's say, since the very beginning, since the, let's say, writing of the proposal, all the way through the PIXIL's project, let's say, developments, and we are very, very happy to have them. Some of them will participate in activities at this very workshop. And the other, Geoplat, TLS, Spotlight, Avern, and Geode, have become associate partners through the course of the project. I am forgetting here the Institut Cartogràfic and Geològic de Catalunya, which is the sort of the national, let's say, geological center in Spain, which came late, let's say later, even to association, but it's already, let's say, a full member of the board. So hopefully they will forgive my omission here in terms of their label. So the whole, let's say, idea, rationale behind the project is rather straightforward. I mean, we're trying to connect technologies which emerge from R&D centers. So we are, let's say, developing new ideas, new concepts, new algorithms. And our intention is that they end up in companies in full exploitation, let's say, sometime through the project or after the project, if that's the case, okay? And the way in which this can happen is by building what we call software prototypes. So most of our IP, let's say, most of our know-how, at least that one which is developed at the R&D centers, can be formulated as codes, as programs, okay? Those programs, of course, let's say, have initial stages of development, which happen inside the R&D centers. Then they can be formulated as prototypes and hopefully tested in our user board or any other, let's say, even members of our consortium, which are at the business side of things, okay, as you will see later from RTS, okay? So essentially, geophysical exploration with a layer of HPC, high performance computing, to, let's say, to optimize or to improve the performance of those prototypes, and an evaluation of these technologies, okay? This is how we, let's say, want to proceed within the PIXIL project, okay? Here are some examples. You will see much more details later, okay, but just very briefly, okay? So the idea here is that we can act, let's say, in several aspects of the geothermal process. So for example, we have partners like Realtimeseismiccan. You will see later detail, let's say, details about what they do, but essentially they're aiming at improving the logistics or the savings, or obtaining savings in data acquisition and processing, which, as you may know, is one of the relevant aspects of geothermal, which is not a very economically intensive, let's say, application, compared at least with other applications of subsurface exploration, like oil and gas and the like. So we also have partnerships which are aiming at improving seismic imaging tools, okay, so making them more capable or more efficient, okay. And in this, for example, INRIA and Realtimeseismiccan are participating, essentially moving from very crude initial models of the subsurface to much more evolved models by means of using prototype algorithms which can benefit from high performance computing, okay. Also, of course, nowadays, there's a huge, let's say, uptake by artificial intelligence, and there are many derivatives, deep learning, machine learning. So we have a team at BCAM which is devoted to using those tools to improve, for example, the ways in which we can obtain information about the subsurface as we drill, okay, from information by the drilling, the logging, let's say, of the drills, as we, let's say, are drilling the subsurface, which are very, very exciting, let's say, novel technologies for the coming years. Also, we are developing together in BSc and UB. You will see further, let's say, information later. I mean, ways in which we can, let's say, apply novel software, in this case for electromagnetic modeling and potential inversion, to match the results which we, let's say, have observed in the subsurface, and thus help us, let's say, improving our knowledge of the subsurface. This should be overall, let's say, conceptualized, okay, generating knowledge, okay, better models of the subsurface by means of mixing up data acquisition, data processing, and model building by means of direct and inverse modeling, okay. So if we do that and we, let's say, exchange or let's say combine geological information with hydrogeological information, we obtain geothermal models, which hopefully are a valuable asset to help exploiting geothermal energy, which we believe is being underexploited, let's say, in our region at present time. Okay, of course, the connections between geothermal models and geophysics is very, very important, and this is a task which has been, let's say, developed by the University of Barcelona primarily. And well, here are some of the, let's say, of the achievements that we have reached. Sorry, there's a microphone on. If you may just please mute your mics for a minute, this will make much easier the presentation. So here's a list of achievements that we have reached throughout the project, and we expect to have several more in the future. So I think we are being rather successful in the project so far. I'm mildly happy, let's say, or satisfied with what we have been achieving through the project. Okay. Just to mention that you can follow us by both browsing at our webpage or following us on Twitter. We try to keep everybody informed of our activities and other potential activities which are related to what we do in PIXIL. And just a reminder that this is the end of I would say, a nice story of workshops, let's say, that we have been preparing in the last years. So starting at the very first one that we had in July 2020, where it was just the members and the first associates. We invited a bunch of selected, let's say, other SMEs and associations which were kind enough to participate and ended up becoming also our associate partners at the moment. So this was the first event that we had. The second one was held in early 2021, and this had, let's say, a broader participation. It was, let's say, a different generation of workshops where we had, for example, EJ, Gidae, Cardial, Ion, and others participating. Of course, always all our partners are participating, and our associates also are invited to participate in the workshop. In this case, we also co-hosted this event together with a different project called Geothermal, okay, also associated to the geothermal energy. And the third and last so far until today has been organized by UB. Sorry, this let's say the labeling would be wrong here. And we also had the participation of BRGM, Imagier, CGG, and other excellent partners. Okay, so again, this is the, let's say, the final legacy of PIXIL. I think these workshops have put together activity from, let's say, from the industry, from people which are interested in these technologies, to the practitioners, and I'm very satisfied and happy that this is happening. Unfortunately, online, as we know. Hopefully, someday we will have follow-up projects where personal, let's say, interaction will be possible. So that's it from my side. Thank you very much, and yeah, and I give the mic to Julien.
Okay, thank you, Josep. So. Just to complete what you said at the beginning, I co-organize the workshop with the help of Pôle Avenia. So I would like also to thank Emmanuel Robin, Nicolas Gontier, and Jérôme Gouin, and also with the help of Realtimeseismiccan, so mainly Jean-Claude Puech, who will talk after that, and the help also of Geoplat, and Paloma Perez and Margarita De Gregorio. Maybe I forgot someone. I apologize if it is the case. I will say it again in the conclusion, and so also thanks to the interpreters for that. So I don't know if there are any questions to Josep. I'm not sure this is a talk that leads to questions. This is mainly an introduction, but I'm just asking in case. I just wait 30 seconds in case there is some questions. And in the attendance, yes, Jean-Claude, you can start sharing your screen. So I said to Josep, so I think you was here at the beginning also, Jean-Claude. So do not forget to go to the English room for your talk, or to the room where I would call the room nothing, or the room without any name. Just to be sure that you are on the floor.
So, sorry, can you confirm that I'm in the...
I think that if you are not,
yes. I am in the English channel, and I hear you perfectly. So I believe that you are doing things right.
Okay, that's fine then.
Okay, so Jean-Claude is from the company Realtimeseismiccan, which is the main, so the industrial partner in the PIXIL workshop, and so we will present the contribution of Realtimeseismiccan, and he will show what kind of contribution can bring Realtimeseismiccan to a project like PIXIL. So Jean-Claude, whenever you want.
Okay, so thank you for the introduction, Julien. Yeah, so I said, my name is Jean-Claude Puech. I belong to Realtimeseismiccan organization. Realtimeseismiccan is a is a seismic service company based in Pau, in the southwest of France. And we are offering seismic services. You'll see the detail. I've named my presentation, what contribution an SME like Realtimeseismic can bring to an R&D project like PIXIL. For those who are not familiar with the acronym SME, it stands for Small and Medium Enterprise. It means that we are a small company of less than 20 people currently. So I've tried to make this presentation simple and accessible to a diverse audience. So we'll see if I succeeded. Okay, so first slide, a few words about who we are and what we do. So we define ourselves as an SME, providing state-of-the-art services in seismic acquisition, in processing, in monitoring and survey modeling. So we provide services basically around seismic data. We do not define ourselves as a startup because first of all, we are self-funded and we've been profitable since the first year of existence. And secondly, we did not build the company around a single innovative idea like startups generally do. As you can see on this display on the right, we provide conventional services like processing, that's our key activity, acquisition support, microseismic and borehole seismic. But we also have an R&D department that develop ideas, innovation, and test new technologies. And this is what you're gonna discover in the next slides. But before jumping into technical things, where again some general slide about the partnership within these projects. So we have 6 partners, as Josep said, located in Spain and France. So the 4 first ones are very well-known academic institutes. So BSc, Bilbao, University of Barcelona, and INRIA. Then after we have Pôle Avenia, which is a professional association gathering more than 200 associated members operating in geoscience, from the largest one, which is probably Total Energy, down to single-man companies. And then ourselves, who are SME of currently 12 people. We are all geophysicists. And somehow in this landscape, Pôle Avenia and Realtimeseismic, a little bit of a peculiarity because we are not academic people. So let's talk about the topic that gathered us today, which is geothermal. So the introduction slide here is quite conceptual. It's something that I shown in previous workshops. So sorry for the ones who've seen that already. But it aims at illustrating how you can expect the quality of a service, like for instance subsurface imaging, to improve with the engaged efforts. So basically on this conceptual display, you have the quality on the vertical axis and the efforts on the horizontal axis, whether we talk about price, time, or resources, whatever. And I'm sure that you all feel this curve behavior almost every day. The curve is obviously asymptotic, which means that getting close to the perfection is, after some time, very expensive in terms of effort, and very often not reachable. So oil and gas operators over the past decades tended to position themselves on the plateau of the curve, thanks to the large financial capacity to fund projects. But the geothermal operators evolve in a totally different business environment due to strong budget constraints. They usually position themselves in the part of the curve where they have to go for heavy compromises. That's what I represented here. And that impacts dramatically the value and the quality of the data input, and very often jeopardizing the project success. You see the bottom line of this, or the bottom sentence of this display. I said geophysics industry can do fantastic things, wide azimuth, multi-component, high-density seismic, but these fantastic technologies are just not affordable to geothermal projects. In the end, the question is, can we do something to change that fact? Can we do better without systematically injecting tremendous efforts and money? And all the topics that we have worked on during this PIXIL project were around the idea to provide good enough geophysical methods at a reasonable price, which means affordable for geothermal industry and operators. So our contribution within the project, this slide is a general slide, like a management slide, sorry for that. It lists the contribution of our SME to the project. So we collaborated with these academic institutes that we coded previously on technical R&D topics. We investigated, developed, implemented, tested new methods and technology that we wanted to be beneficial for geothermal operators. We promoted our achievements to our customers and implemented those achievements for their benefit. We obviously enlarged our professional network, and hopefully this project made us more visible overall, which is crucial for a company of our size. We are not Schlumberger, obviously, and it helps promoting our portfolio of services. Okay, so this slide is a slide on the list that lists the different technical topics we worked on. So we worked with INRIA at developing and fine-tuning a full wave inversion code for surface wave characterization. This topic is a very challenging topic, and Chengyi Shen from INRIA will present what was achieved in more details just after my talk. We helped at introducing the last generation of single node seismic sensor in the geothermal industry, at least in Western Europe, but overseas also. We ran several tests in 2020 with geothermal operators and convinced them to adopt this technology, allowing to reduce significantly the cost of seismic operation. I will go a little bit more into details of that achievement later. In the same spirit, we promoted, designed, and implemented the concept of what we call the frugal seismic, consisting in implementing light asset seismic acquisition, minimizing the number of shots and receivers without jeopardizing the geoscience objectives. Again, the objective is to turn the technology affordable for geothermal operators and geothermal projects. We conducted a test using fiber optics deployed in a well by two very affordable and simple covariance means. I'll show you more about that in a few minutes. We have developed a simple, robust, and efficient automatic first break picking algorithm. There will be a couple of slides on that as well. We developed a new technology or methodology to produce velocity models from travel time picking without running through ray tracing. We named it TNT, Tomo non-Tomo. We also worked at implementing a frugal acquisition systems for passive seismic monitoring for microseismic, and some other topics that we do not have time to present here, but there have been more things. To illustrate these works, the next two slides show what we call the concept of frugal seismic, where we pursue the idea to reduce the amount of equipment required for seismic surveys to turn them affordable. The innovation here is more on the receiver side, where we have compared the previous decade technology, the white and blue here on this picture, with the new generation of autonomous sensor, the orange one. These new nodes are proposed by Stride, a British company. They are smaller, they are lighter, they are cheaper. Therefore, they allow a much higher efficiency and significant money saving in the end. They appear key to lower down the total cost of the entire operation by a significant factor. You see here, I put some factors, all what we have gained by moving from one generation to the other. And in terms of quality, our work consisted in demonstrating that from the first projects that we participated to, that the image that we obtained were equivalent. So we were like a pioneer to promote this technology, because we found that it was a lever for the geothermal industry to access to a high quality seismic surveys. So the next slide summarizes the success story of the first project that we did, and there were some others. So here you see two vibes of 44,000 pounds, 1,000 shots were recorded, 2,000 nodes were deployed in the field, which is it's not a big acquisition at all. 3 days of acquisition in a semi-urban and urban area. You will notice the arrows follow. So what you see here at the screen is the star is the source, and the rest of the display are receivers. And we basically look at the movie of the acquisition from the first shot to the last one. And the color coding represents the energy which is recorded by each receiver. You see that there is a traffic. It corresponds to road traffic because we are in a urban area, yeah, in what we obtain in the end, so what we're telling in the end, although we do not record across a 3D regular grid like usually we do in open conditions, what we obtain is a 3D cube of excellent quality. On the right, you see an extraction of a 2D profile that we could manage to obtain as part of this project. So despite a very light and frugal acquisition, we managed in reconstituting and producing a cube of data of high quality. Another topic that I mentioned in my bullet slide, previous bullet slide, is the automatic first break algorithm that we have developed, and we carry on improving at the moment. First break picking is obviously a very mature topic in geophysics, because it is a very essential technical brick for all geophysical applications, and this since the early days. For a 3D survey with millions of traces, not the one that I showed previously, but large surveys, there is no other way than relying on automated algorithms to pick first breaks. So our goal was to assemble different ideas to make a simple, robust, and good enough picking algorithm to reduce turnaround time and speed up a very tedious and time-consuming step of the processing sequence. On the left side, the display shows the result of first break picking on a row shot. You see the row shot waveforms in the middle. So we compare here the picking obtained manually, which is in blue, with the result of the automatic picking algorithm, which is in green. On the right, so the approach is carried out in different steps. On the top right, you see the difference between the first step of the automatic picking process and manual picking. You see that the red crosses show quite a lot of scattering. But at the third stage of the process, the bottom display here, you see the difference between where the result of the manual picking and the automatic picking and the manual picking. The black line that I draw here indicates what we're trying to achieve. Basically, we're trying to get as close as possible to the manual picking. You see that it's not perfect at the very far offset where it becomes challenging. On this display here, you can imagine here the difficulty to pick the first arrival, even with the eyes. It's challenging. But globally, it's very satisfactory, or we find it very satisfactory. And after verification, the outliers, the points in the red bubble here, are badly positioned because of a wrong manual picking, not because of the result of the algorithm. So this slide is about the result obtained in 3D after automatic picking by our algorithm. You see that despite the fact that the data is not very clean, there are noisy traces, noisy signals, the algorithm is able to produce very stable results represented by these green dots. We believe that the beauty of the method resides also in the fact that there is almost no parameters to fine-tune. So the use is very simple. We wanted the algorithm to be simple to be used, so that the user don't spend half a day or a day to fine-tune some parameters. So changing to another topic, this following slide is about a vertical seismic profile that we recorded as part of a pilot test in Vauvert. You see, well, it involved different partners that are not directly part of the PIXIL project. So Vauvert is in the south of France. For the people who works in France, they probably know where it is. So what we basically do, you can see what has been done on these pictures on the right. We deployed a wireline cable containing a fiber optic inside. This cable is a simple cable usually used to deploy a camera for bore investigation. So it was not a dedicated cable for this application. But in that case, we plugged a DAS interrogator. You have the picture here of the DAS interrogator, which is an optical system that interrogates the fiber in the well. And we managed to record a nice VSP. So the data recording itself took about 20 minutes. Basically, we had to vibrate 60 times to increase the signal-to-noise ratio. But the technology allows to record a VSP at each vibration, basically. And you see the result obtained on the right after a very mild processing. We manage in imaging nicely reflectors that the well cross, and that was quite a very good results. We're very happy with the result. So again, a very affordable acquisition technology for VSPs. And we also, as part of this project, we also tested the fly technology from WellSense. So WellSense is a Scottish company, and they propose this fly technology. Fly stands for fiber line intervention. So the technique consists in dropping a torpedo containing a ball of fiber, which is unrolled in the well as far as the torpedo falls down to the bottom. It takes about 20 minutes. We took 20 minutes for the torpedo to go down to the bottom of the well, which is located at 800 meters. For the rest, the acquisition of once the fiber is deployed, the recording is the same as for the previous experiment. We have a vibro size at surface, and while the vibro size vibrates, we integrate the fiber with the DAS interrogator, and we obtain what you see on the right. So the quality with this way of conveyance is not as good as the wireline test in this case, because here the well is vertical, and certainly if we had a slight deviation, it would help to get a better result. But the first arrival is pickable. It's not very precise, but it's pickable. And we found out, analyzing carefully the results, that the depth control is better in that case than with the wireline cable, because the wireline cable requires a slack, to put some slack on the cable, to put more lengths of the cable in the well to ensure the coupling with the bore side. So that's not the case with this technology. And also, we were surprised by the quality of the result in the shallow interval. We found it better with this technology, with the fly, than with the wireline. But one difficulty of this is that of this technology is that it's heavily sensitive to contamination by tube waves. And here, the display dilation have been quite heavily processed to remove the tube wave that was contaminating the area of the first arrival. So we reached the end of my presentation. I put here as a conclusion slide the list of the public publications that we have submitted over the past 2 years. So there's quite a long list, and in the next months we will work at submitting more things, because we are at the end of the project, and you know that at the end of things accelerates. So yeah, thanks to PIXIL, all these works, and I did not present everything that we did, but all these works of R&D could be realized, and that was quite a successful project for us. Thank you for your attention. That's if you have some question, I'm available to answer.
Okay, so thank you, Jean-Claude. So as Jean-Claude said, if you have any question, please, you can open your microphone, if possible, in the English channel, so that you can be translated. Okay.
Was I so boring that nobody wants to talk?
So maybe I have one question for in the framework of the. So Pierre has asked something in the. So thank you for this review. So maybe I have one question for you, Jean-Claude, on the future of all this activity. Do you think you can do this in a collaborative project? Would it be interesting to collaborate with some other people? So either in the associate partner here, or I don't know. I don't ask you to mention name, but do you think that in the Pyrenees you can continue a collaborative project on this topic?
Well, certainly. I mean, we are open to give you a little bit of context. All these works that were developed or investigated are already applicable for operators, and So there is not so much, so many geothermal projects in the Pyrenees or area yet, but we made operators operating in particular in Belgium and in Switzerland, and sometimes also in France, to benefit to all this work that we developed. So yeah, now it's a question of shaking a little bit the geothermal project activity in our southwest region of France and north region of Spain. For the time being, it has been pretty quiet. And as far as the collaboration with local companies are concerned, as you can see on this slide, for instance, Gallego Technique Geophysics is a company based close to Toulouse. Phoebus is also a company based in Pau. So we have already developed some common projects with those partners in the area.
Okay.
I should also mention Geo Solutions. So we had some, but probably Chengyi Shen he will mention that. But we had some exchanges regarding the full wave inversion and the meshing aspect of the things with Geo Solutions. So Geo Solutions are based in Pau, and they are specialized in meshing, in mesh and simulation overall.
Okay.
I hope that I answered your question.
Yes, yes, yeah. Thank you, Jean-Claude. Is there other question to Jean-Claude? So if not, first I would like to apologize because when I mentioned people who helped me to organize this workshop, I completely forgot the BSc. It was so obvious that I forgot them. So there was also Mireia Kospik who helped me to organize all the workshop, and of course Josep. So I think it is time to go to the next speaker. So I hope the next speaker sits right next to me, so I hope there won't be some interferences. So I will cut my microphone and also my earphone. So if you don't hear Chengyi, just write it on the chat because I will hear him directly from in the room. So Chengyi, can you first try to, before I cut my microphone, try to share your presentation? Yeah, yeah. And so Chengyi will present the work that we have done in collaboration with RTS, and as Jean-Claude said, a bit of it has been done thanks to meshes provided by Geo Solutions. So I think we can see the slide. So I will just cut my microphone, and so just the title. So we will talk about the use of the inclusion of surface waves in full waveform inversion. So just 1 second.
Thank you, Julian, for the introduction. So hello, everyone. My name is Chengyi Shen, and I'm currently working on full waveform inversion in INRIA's Makutu team. And we are tightly collaborating with Realtimeseismiccan within the PIXIL project, as Jean-Claude just presented. Okay. And in particular, we are focusing on the surface waves. So to start, Josep just given thorough presentation on PIXIL, so I'll just go quickly. So let me quickly remind you that the PIXIL project aims at creating an international network where people share their imaging experience, especially in the region along the Pyrenees, where there is a real potential of geothermal energy exploration. The main Spain participants include the Barcelona Supercomputing Center, the University of Barcelona, and the Basque Center for Applied Mathematics. On the French side, INRIA, Pôle Avenia, and Realtimeseismiccan are the main, some of the main actors. During our teamwork with Realtimeseismiccan and Avenia, we also had an appreciable exchange with Geode Solutions and used their machine solutions on our studies. And finally, the project covers a Trans-Pyrenean area with about 15 million residents. Now let me introduce briefly the full waveform inversion, which is a cutting-edge inversion method for imaging in general. It is a multi-level and iterative method where each iteration consists in comparing the synthetic full waveform solved from the forward problem and the data, also called observations, and generally registered on the surface of a field. And then misfit function is minimized, followed by a model update. As you can see in this video, we started the inversion with very approximate guess model of the medium and run the full waveform inversion for each frequency. A new model is obtained after each iteration, and more details are uncovered as the inversion level grows. Images from full waveform inversion are expected to have much higher resolution than seismic tomography, mainly because it takes into consideration the whole waveform. It offers also numerous mathematical and numerical options that can help with a robust and precise reconstruction of the subsurface, such as the kind of misfit functions, the way to estimate the distance between the data and the simulation. So the full waveform inversion is capable of uncovering small and sharp variations in an imaging context. It has a great potential in both geophysical and medical imaging. Our final goal is to apply this method on real seismic data for geothermal exploration. Now let's look at some the surface waves. Surface waves carry useful information on the near surface geophysical properties, which is widely used in civil engineering, for example, to investigate soil resistance. And this subsurface geophysical information is also needed for both shallow and deep geothermal projects. However, in a conventional seismic exploration, surface waves are generally cleaned before doing any inversion or migration because their behavior are very different from other waves, and it is quite tricky to take them into consideration. But we can do something with them. For example, real-time seismic is specialized in surface wave analysis from which we can retrieve S-wave velocity models. And full waveform inversion may consider the surface wave and explore it in a comprehensive way. So now let me introduce some details on surface waves and the numerical tool that we are using for the full waveform inversion. Since seismic acquisitions are always done in the time-space domain, we first used Houdini an HPC code written in Fortran by INRIA's Makoto team to simulate wave propagation in this geophysical model featuring 2 cavities. The receivers are placed on the line on the surface of the model. And here you see an illustration of the surface wave propagation in time and space domain. Surface waves are slow and dispersive. On the top of the figure, you see the propagation of the surface wave in this 2D medium. On the bottom, you have the corresponding seismograms registered by the line of sources. The surface wave feature strong amplitudes and arrive much later than the first arrivals. Now let's look at one of the seismic signals. On the top, you have one of the signals, and we separated the first arrival, a P wave on red, and the surface waves in blue. Because the full waveform inversion will be performed in the frequency domain, we will need to know the Fourier transform of the signals. So we performed Fourier transform on these 2 signals, and we obtained the 2 following figures. The second figure in the second figure there is it is the Fourier transform of the P wavelet. We see that the peak frequency is at about 30 Hertz, and the curve is quite smooth. In the third figure, you got the Fourier transform of the surface wave. It is very different from the second one. First, the peak frequency is located at about 13 Hertz. And second, the amplitude varies intensively, which means that a very small frequency interval is needed to well sample the surface wave. We used a numerical code called Howin to perform full waveform inversion in the frequency domain. This code is written in Fortran by Florian Fauché of Makoto team of INRIA. Here you have the website. It is highly parallelized code, and it is designed to perform both simulation and inversion in the frequency domain. And it uses the HGG method, namely hybridizable discontinuous Galerkin method. The HGG method is particularly adapted to high performance computing and is compatible with both mesh size and polynomial adaptivity. It will naturally reduce the global number of degrees of freedom compared to the traditional discontinuous Galerkin method. In terms of parallelization, Howin uses both MPI and OpenMP. Here you have an example of the domain distribution on different CPUs by MPI. MUMPS is then used to do matrix decomposition and inversion. Now we have all the numerical elements for solving the wave problem. We can handle first the forward problem. A seismic source is activated on each surface source position and sending seismic wave into the medium. On the other side, you have the receivers that register the signals, also called observations. Then the difference between the observation and the real data are calculated, which is called residual, and this residual is then propagated backwardly from the receivers to the sources, which is actually solving the backward problem. And this leads to the adjoint state. The objective of such a process is to minimize a misfit function with the conjugate gradient method. HAWEN features a number of misfit functions constructed in the frequency space domain, and they are validated by numerous synthetic tests. However, the most common domain where we address the surface waves is the frequency wave number domain. So one of our main tasks is to construct a new misfit function in this domain and test it. Besides an appropriate misfit function, a successful full waveform inversion will also need some data of quite good quality, a well-guessed input model as input model, carefully designed multi-level strategies, and some filtering techniques. And finally, both Bash and Python programs are created to assist the Fortran code execution and data processing, among others. Now we got the numerical tool. We did a case study on synthetic data. We came up with this synthetic model featuring 3 layers with 2 cavities on the second layer and a vertical wall to the right, as you can see in this figure. The 2 cavities have a side length of about 3 meters, and the sources and receivers are located on the surface and covers the whole zone of interest. With this the space between neighbor sources or receivers is 1 meter. Below the geophysical model, you have a table displaying the main properties of each layer and the cavities. For example, the highest S wave velocity is above 2000 meters per second here, and the lowest is about 300 meters per second in the cavities and in the first layer. These values show that this model is characterized by strong variations and contrasts in terms of elastic wave velocities. We then generated a synthetic data set in time with this model by Houdini, then transformed them into a frequency data set and ran full waveform inversion on them by HAWEN, with the misfit function constructed in the frequency space domain. The multi-level results is displayed in this video. We started at about 4 Hertz with the initial model, with a partially smoothened initial model, as you can see here, without any of the cavities. The inversion is then conducted by groups of frequencies. And in total, we used about 400 frequencies. As you can see, the 2 cavities appear at a dozen of frequencies, and the contrast with the background became stronger and stronger as the frequency increases. However, strong and sharp artifacts appear also as the frequency increases. Here you see some of the horizontal sections crossing the 2 cavities at different frequencies for both the SP wave velocity and the S wave velocity. Blue curves correspond to the full waveform inversion results, and red curves are the true values. From top to bottom, the frequency increases, and it is obvious that the cavities are showing up more and more clearly. In this figure, you see some of the vertical sections crossing one of the cavities at different frequencies. From left to right, the frequency increases, and the cavity is difficult to reconstruct at the lower frequencies. But at higher frequencies, it showed up, as you can see here, at about 5 meters deep. This is not surprising because generally the resolution in the vertical direction is poorer than in the horizontal direction. So the two cavities are well located by the full waveform inversion, especially in the horizontal direction. And the reconstruction of the P wave and S wave velocity inside the cavities are pretty satisfying, even though their values stay higher than the true values. However, some sharp and noisy artifacts appear in the full waveform inversion models as the frequency increases. And we believe that more efforts should be done on regularization, filtering, and the construction of misfit functions. And this could help us attenuate these artifacts. After the case study on the synthetic model featuring the two cavities, we went on to real data. The real data are acquired by real-time seismic in a seismic campaign. And here you got one of the seismograms from the data set. On this seismogram, we can easily identify the first P wave arrivals and the surface waves, as well as calculate approximately their velocities. There are in total about 200 shots, and real-time seismic performed a surface wave analysis on the entire data, on the whole data set, and they obtained this S wave velocity model. They then deduced P wave velocity model from the S wave velocity model. And we expect to improve this S wave velocity model by full waveform inversion. These two models are then used to generate a synthetic data set by Hawen. Here, we show a visual comparison between the real data and the 2D synthetic data in the time and space domain. We can easily identify the corresponding P waves and the corresponding surface waves. Below you have the same data represented in the frequency space domain. They seem to be very different, and a quantitative comparison between them will be difficult. Now let's transform the data into the frequency wave number domain. And in this figure below, we can see comparable P wave patterns and surface wave modes. So we can imagine that quantitative comparison between them should be more convenient. We then calculated the misfit function along a given model path, which means that we created a series of models around the true model from a very approximate model to the true one in the middle until another approximate model. We performed simulations on all the models and then compared them with the reference data. So in the frequency space domain, the misfit functions are displayed in these curves for each frequency. It is clear that these misfit function curves have a very narrow attraction basin, which means that we have to start from an initial model which is very, very close to the true model to convert to a best model. However, if we look at the similar curves in the frequency wave number domain, we see that the misfit function curves have a much larger attraction basin. This infers that we got a bigger chance to find the best model from a relatively fluid initial model. So in conclusion, The full waveform inversion on the synthetic data set using the model featuring the cavities indicates that the misfit function in the frequency space domain may allow to reconstruct cavities, but we probably need to start the full waveform inversion with a highly precise model. The misfit function in the frequency wave number domain yields a larger attraction basin, which means that we can expect a successful full waveform inversion from initial model of much lower precision. The next step will be the establishment of suitable full waveform inversion strategies with this misfit function in the frequency wave number domain. Special attention should be paid to the regularization and filtering techniques, not to forget the target parameters in the full waveform inversion. Thank you for listening.
Thank you, Chengyi. I just switched to the English channel. Okay, so do you have any questions for Chengyi? We still have time for questions, and there is a break just after, so do not hesitate if you have. Okay, so
Julia,
yes.
It's not a question because I don't have a question as I followed this project quite closely, but just a comment. Well, the goal that we were after in this project was both to characterize the subsurface, as explained by Chengyi, characterize the subsurface using surface waves. And the second goal was to clean the signals, the seismic signals from to clean the signals by removing the surface wave signals, so that it gets we can get a clear image of the deep intervals. So we knew that it was very ambitious because there have been some theses, PhD on that, and they basically had faced a lot of difficulties. So we knew that it was very challenging and very ambitious, and I think that's also what we faced during this work. It is a difficult topic.
Yes, I think it requires indeed more than two years or even 3, thanks to the extension. But yes, as Jean-Claude said, the second topic is challenging because it depends on the first. If the first topic is not achieved, we cannot tackle the second one to clean the domain. And the idea was to go back to time domain at the end, so that the idea is once we have a better understanding of the shallow subsurface, to try to generate the signal in time domain and to identify the surface waves and to remove them from the.
Yeah, but it's challenging because while the surface waves are very dispersive, they are subject to a lot of diffraction. Every time there is an heterogeneity, there are diffractions. So it's very difficult to reproduce using a synthetic. To reproduce exactly the same character of the signal to be able to remove that from the signals.
Yes. Okay, so thank you, Jean-Claude, for the comments.
Thank you, Jean-Claude.
Do you have other questions? Okay. If not, I think we can make the break now. So on the program we have to, so the idea was to have a break until 11. So I won't disconnect, I will simply shut the microphone stop the video, except if Guillaume or someone from the interpreter has something to say about the technique, or is everything okay on your side? No, okay. So everything is okay. So I propose to have a break and then we will start. I will connect 5 minutes maybe before 11 to install the next presentation. So it will be a presentation by David Pardo just at 11. So see you at 11.
Okay, thank you.
Okay, so it's, I think we are on time. So we will start again with a talk of David Pardo, and so we will talk about deep learning for geophysical measurement. So not for geophysical measurement, but for inverting geophysical measurement. Okay, so David, whenever you want.
Okay, so thank you very much for the invitation. I will be short, so I will not take the full 30 minutes. This is a little bit more technical topic, and perhaps the application is less straightforward than the previous ones. So what I have decided is just to mention some of the main ideas of what we are trying to do, because we believe that we will see more and more of the use of deep learning and artificial intelligence in general for exploration of the Earth's subsurface. So I will just show the main ideas, and then I will provide a reference to the publications we have delivered during these 2 years within the PIXIL project. And by the way, we are very thankful to the Barcelona Supercomputing Center and especially to Josep de la Puente for inviting us for this project and all the other partners as well. So let me start with it. So for that, let's begin with our background. Our background was on modeling resistivity and acoustic borehole logging measurements using finite elements, traditional finite element methods, and so on. And by the way, we just published a book last year. And the main idea of this is the following. We have an Earth model with some values of resistivities or velocities, seismic properties, and so on. We solve some partial differential equations with boundary conditions, etc. We obtain a solution, which could be the electromagnetic fields or the acoustic pressure, and then via post-processing we simulate some measurements which are supposed to be similar to the measurements we observe when we do this logging while drilling or these geosteering operations. So this is a so-called forward problem. And the inverse problem is the one of interest here and the interest for the geophysical community, in which you obtain these measurements using this logging instrument, and you want to recover what are the Earth properties of the subsurface. So for decades, we have been using finite difference, finite elements, finite volumes, in other words, traditional numerical methods for this. And what we are exploring here is how to use artificial intelligence for doing this task, that is solving this inverse problem. And as I said, this is a bit technical, so I will just provide the main ingredients, and I will give references for those of you who are interested, or feel free to contact me or whatever you prefer. So the idea is the following. These are the measurements. This is some log we obtained there, and we want to recover the Earth properties. In this case, if we have a rock on the subsurface, we want to know if it is water saturated or oil or gas saturated and so on. And for that, we use this thing that is named as a neural network and usually represented by this. And it's a complicated way of what for me is easier to explain, that is a composition. The symbol means composition of functions where these ones are the so-called affine mappings, which are basically almost a linear mapping, and this is a nonlinear function. And basically what we are trying to do is to approximate this inverse operator by this approximation, which is given by a composition of these functions. Okay, this is what neural networks, which is a very important field within artificial intelligence, is about. So, to start with, let me consider two models. In here we have a two-layer model, and here a different one. And if we consider a logging instrument with a so-called coaxial component that goes on the horizontal direction, we see that the solution we record in both of them is the same. The measurements we obtain is the same. Therefore, the inverse problem does not have a unique solution. The solution is non-unique. You may have multiple Earth models that satisfy the measurements. And this is an essential problem here that it will go through the entire presentation, and we will show ways of how to cope with that problematic. So in here we consider two typical logging instruments. This is a typical logging while drilling, where the distance between transmitter and receiver is approximately 1 meter. And this is a deep logging instrument that the distance between transmitter and receiver is much bigger, it's about 12 meters and so on. Those are the typical commercial logging instruments some people use in the oil industry. And what we are trying to do is, given a logging trajectory, here is one point of the logging trajectory, specified here with the letter T, we want to determine the Earth model. And for that, we parameterize with 5 numbers. This is the distance from the logging trajectory to the upper layer, to the lower layer, and the resistivities of these 3 layers. Okay, so we assume this is a 3-layer model. This is just for simplicity. Of course, we can make this much more challenging and difficult, but it will be more difficult also to illustrate it. So let's start with this particular parameterization. And what we have is a forward problem, which we represent with the letter F, an inverse problem with the letter I, and the neural network approximations, which, as I said, is a composition of affine, or if you want, linear and nonlinear mappings. And what we are trying to do is to first approximate the forward problem by minimizing the misfit of the data. This is the Earth properties, and these are the measurements. And then we solve the inverse problem by requiring that the composition of both is the identity, because the inverse should be the inverse of the forward, which means composition of both of them is the identity mapping. So again, I emphasize, I didn't go into all the details, so understanding all the intrinsics of all of this is difficult, but let me just show you some of the results we obtained. This is our original synthetic model. Red here means a resistive layer, where, for example, oil-bearing layer, and blue, a conductive layer, for example, a water-bearing layer. This is the trajectory of the logging instrument, and these are the results of the inversion based on the synthetic measurements we recovered. And as you see, it may seem that these graphics are different from each other, but they're quite similar, because the depth of investigation, that is how much these logging instruments can see, is approximately 4 or 5 meters. So the most you can obtain is 5 meters above and 5 meters below. The rest, they are unable, these logging instruments are unable to see what happens after that. But as you see, close to the logging trajectory, we recover a quite good, not perfect, but quite good representation of the Earth model. In particular, we can anticipate here that there is some water-bearing layer, and therefore we can try to change the trajectory in real time. And the same happens here. So it's quite good identifying the water-bearing layers, which is one of the properties this method should have. So far, so good. And These are a number of references here. For example, in the second one, we analyze the measurements when you add noise, if we can recover similar results, and we do. And for example, the first one was made in collaboration with Equinor and Baker Hughes and Northe, which is a Norwegian institute, and so on. So it's kind of a more practical approach. And also we have the more theoretical ones here, okay, in the last two references. Now, another topic we were investigating is how to design a measurement acquisition system. And for that, again, without entering into details, we selected two different commercial logging instruments, very similar to the ones we showed before. And the objective was, instead of having so many transmitters and receivers, select only the ones that were necessary in order to be able to still recover the Earth subsurface properly. In other words, do we really need all these transmitters and receivers, or can we use only a few of them like these ones? And it turned out that with this deep learning, with this artificial intelligence method, it was very easily to construct an algorithm to select which transmitters and receivers should be employed during geosteering operations. And I will show it with an example here. This is the same original model as before. And this is the inverted model when you use only one transmitter and receiver, just one measurement. So this was a complete disaster. It has nothing to do with each other. But as we added more optimal transmitter and receiver combinations, with just 4, we obtained an okay inversion, not perfect, but more or less okay. And with 8, we obtained an extremely good inverse method, so that actually better than what we obtained before with any of the commercial logging instruments. So we designed a new logging instrument by using this artificial intelligence method, where with just 8 different combinations of transmitter and receivers, which is not so much for commercial logging instruments, we were able to recover the Earth's subsurface. This was another topic. We produced another paper, and I found this particularly interesting. And if any of you has any interest on these things, because it can be applied to different fields of knowledge, please feel free to contact us and so on. Now, 2 more topics we are working on right now is that when it comes to deep neural networks or artificial intelligence algorithms, one needs to design what they call the architecture. How many linear and nonlinear functions you want to put there and how you want them to be. It turns out that there's a topic in artificial intelligence called automated machine learning that can try to design this automatically without any user interaction or with minimal user interaction. So in that way, it will become much easier to design these methods rather than having an expert with a lot of knowledge on the topic. So this is what we did right now. And it turned out that we were able to produce a neural network architecture that was much cheaper or smaller without losing accuracy. So the accuracy is represented here on these 3 plots. This is the original one. This is the inverted with our original network, and this with the one designed by the automated machine learning. They are very similar in terms of accuracy for practical purposes, while the time employed for computations was diminished from 19 hours to 12, and in here from 34 to 15. So instead of 2 days or 3 days of computations, we reduced it to 1 day. So it was okay. Of course, we are still working on the topic, and we are finishing an article on that, and we'll have more details then. And also another of the topics that is of great interest is the so-called active learning. Basically means how many data samples, by data samples, each of these samples means an Earth model. How many Earth models you need differently to train your neural network. Because if you use many of them, you will have a very high computational cost. So you want to minimize the number of samples you select. And what we did is basically select a few samples and then apply the so-called active learning algorithm, which is known within the artificial intelligence community for the last couple of decades, to add iteratively and adaptively different samples here, okay? And in that way, instead of selecting all points, which is very expensive, we only select the ones that are marked with this blue cross, and this is a cheaper algorithm. And again, this is a work in progress. We don't have full results yet, so partial results I think are a little bit confusing, so I prefer to avoid them altogether. And simply I will go with the conclusions. I think deep learning is an area of artificial intelligence of great interest in multiple applications, and is becoming more and more used in geophysics. Instead, if you select any journal in geophysics, more and more papers appear based on deep learning. And I think it is possible to invert. In here, we are doing it with borehole resistivity measurements, but I think we can use it also for magnetotellurics, for control source electromagnetics, and so on, to reproduce or to discover or to find which one is the Earth subsurface model given some measurements. So this is an area of very active research. And I know many of the oil companies, Equinor, Baker Hughes, Halliburton, Schlumberger, Repsol, all of them are investing huge amount of resources and money to go in that direction. So I think we need to be aware of that. Then we also propose some iterative algorithms to design logging instruments based on these technologies. We also work on the so-called automated machine learning and active learning to make things cheaper, because these algorithms otherwise are also computationally very expensive. And I didn't show any of that, but I have a postdoctoral fellow working intensively also on the use of these algorithms for seismic processing. And there is a plethora and an explosion of articles on the topic in the last year and a half. So it seems it is faster and easier to interpret or to process seismic measurements using this technology. So this is all I wanted to say for now. If you have any question, please feel free to ask and so on. Thank you very much.
Thank you, David. Do you have any question for David?
Yes, this is JC speaking. David, can you go back to one of the slides where you show the results? Maybe one of the first ones, yes. So here you simulate a drilling from left to right. Am I correct?
Yes.
Okay, so if we imagine the drilling bit, yeah, on the way up, yeah, where we were, on the way up, when you pass the inflection, the low point. No, yeah, when you arrive on the vertical interface that you have, yeah, here at that point. So if we imagine that we have the drilling bit approaching this interface, if we imagine that we are a little bit few meters behind, or when we're approaching this point, basically we don't have, if I understand well, that we don't have the mean in that particular configuration to detect that we are approaching this interface.
Yes, I understand perfectly the question. 100% correct, and it's just on the spot.
Yeah, if you are,
yes, I mean, this is what is called.
Yeah, if you are here, for instance, the data that you record and that you analyze don't tell you that you have an interface in front of you.
Yes, let me give you an explanation. This is what it is called ahead of drill. And now with this technique, the way we parameterize the Earth, the way we did this parameterization, this one, is impossible to know anything ahead of drill. Okay, so if you want to know ahead of drill, which is a very practical issue, we will need to do something different. But this will be more complicated. In other words, we need a more complicated Earth parameterization. Can we use it? Yes. Can we do it?
Okay. But on the other side, on the other side, let's say where at the horizontal position 180, for instance.
Yes.
Go to the left. Go to the left. Left. 180. Again, left. Yeah, here, for instance, you start to feel that you're approaching the interface because you see that there is a kind of convergence of the, or reduction, let's say, of the red color.
Yeah, but we are not seeing anything ahead of drill. What we are seeing is only vertically. That
yeah,
is,
but
we are having horizontal. I mean,
yeah,
we are having horizontal. I'm sorry, vertical knowledge of what happens vertically, but not ahead of drill. For ahead of drill, you need different sensors, and you need a different parametrization of the Earth. Can we do it? Yes. Is it much more difficult? Yes. It will involve much more time and effort and so on, and that, yes. But in here, we only did a proof of concept to show that at least the basic concepts, which is, these vertical resistivities, we are able to recover them properly. But I agree with you, from a practical point of view, if you want to put this on the field, you need this ahead of drill, especially when you have these geological faults. That's the part we don't discover ahead of drill. Okay.
Thank you.
Thanks to you. Very, very nice question.
Other questions?
Yes, I have a question. Can you hear me?
Yes.
Yes.
Yes, I'm Jean-Luc Boel from Realtimeseismiccan. In your methodology, you are using the neural network technology for the forward problem and for the inversion. Does it make a difference if you are using more conventional method for the forward problem?
This is also a very interesting question, because this is the main question one asks oneself or himself when you start with all of this. And the problem is the following. This is your forward solver. This is a traditional one with finite elements or whatever. And we are training a neural network here only because in here, if you put the original forward solver, you need to do during training, during minimization of this, you need to evaluate many times this thing. So if this is a finite element solver, because this minimization is typically executed in a graphical processing unit of a computer, you will need to either implement your forward solver in a graphical processing unit, or you need to call the CPU, the central processing unit of a computer. And this is much more expensive. So it was only an issue of computational efficiency. But yes, behind all of this, there is always a finite element method for simulating the forward solver. Yes. Now, there are other methods based on neural networks to solve this directly with neural networks, so-called PINs, physically informed neural networks. But we are not using them here because this is more complicated, they are less efficient, and there's still a long time until they become competitive with respect to finite element methods. But yes, this is one of the very key issues, which, by the way, is very much explained in one of the papers, I think in this one, okay, in the last one.
Okay, thank you very much.
Thanks to you for your question. Thank you.
Okay, thank you. So we still have 5 minutes for questions. So is there anyone who wants to ask a question to David? Maybe I have one on your conclusion when you are talking about machine learning in seismic processing. So what do you mean exactly? Is it the processing of seismic signals, something similar to what Jean-Claude did to pick the first arrival or something like that? Or is it to invert the seismic signal?
No, when you record typically seismic signals, is directly processed and you obtain directly an image. Okay, but this image typically has some problems because they have to do some normal move out correction, and this perform some stretching on the signal, and some things that are unphysical because of the long distance between transmitter and receivers, and this is not very well taken into account in this post-processing method. So we are talking about ways to improve that, so the final image you see, only seismic, not in full waveform inversion, only seismic, the final image you see is much better, much more clear without these stretching factors that you typically see as a result of an incorrect post-processing that typically happens in most of these images, or how to reduce noise. There are some unintended noise artifacts that typically appear, how to reduce them without killing the main signal and without losing essential information, all these kind of things. And we produced like 3-4 papers on the topic with one of my postdocs.
Okay. Thank you for the answer.
Thanks to you.
So we already had a lot of questions, so we still have time if anyone has. Okay, so I propose, so we have 4 minutes, so maybe it leaves time to Octavio to prepare the screen and so on. So thanks again, David.
Thank you very much.
You're welcome. So Octavio, yes. So,
hello, Julian. Good morning.
Hello.
I'm here.
So Octavio, I don't know if you hear at the beginning, but for the talk, it is better if you are on the English channel. So I don't know if you are or not, because I cannot see that. It's just.
Yeah, I'm working on the English channel, I think.
Okay, so that's good.
Yeah.
Can you try to share your screen?
Yeah, just give me a second. So right now, really.
Nice.
That's working, right?
Yes, we can
Perfect.
see it. So maybe we are only 2 minutes ahead. So I think I'm just wondering if we wait. Maybe it's better to wait if someone wants to.
Yeah. Don't worry. We can wait.
So after the talk of Octavio, we will have an open discussion for those who want to participate. So the goal of the open discussion at the beginning, it is written open discussion with associate partners. So the idea was that the associate partners can tell us a little bit of what they think about what has been presented. But of course, it's not limited to associated partners. So if anyone wants to participate, he will be welcome. And so the idea is to have some kind of your opinion of what has been done and what could be done next. So the future, because as Josep said, we are at so PIXIL will end in 3 months. So it's time to think to the next step. So we will be happy to hear your opinion on this. And still we have 30 seconds, I think. Okay, so Octavio, I think we can start when you want.
Okay, Julian. Thank you for the introduction and thank you for the organization of this PIXIL workshop. And the idea is that in this talk, I will try to explain or summarize the main work developed at the PIXIL project in the part of in the context of electromagnetic modeling for geothermal energy. And the idea of this part of the project, of this research line, is that electromagnetic modeling methods are useful for mapping the electric resistivity subsurface. Basically, the idea is that this physical value, this physical property is used as a agnostic physical value, and this property is, or this value, are sensitive to fluids, and also that these electromagnetic methods are one of the most cost-effective among all the other geophysical methods. In our case, we are working a lot on numerical simulation because they have become inexpensive, and they are able, or they are useful to validate our synthetic models by direct comparison between experimental data against synthetic data. And the application of the applicability of these methods is transversal to different applications, different contexts. Initially, in some years ago, we started to work with electromagnetic methods for oil and gas, and now with the energy transition to green technologies, we are moving also to other application, in particular for the geothermal energy context for PIXIL project. But it has other application for other contexts like mineral exploration and volcanology. So basically, in the last year, we were, with these ideas in mind, we were working on developing an electromagnetic code and an electromagnetic modeler using high performance computing. And the net result is the PETCHEM code, which is have been developed in the last years. And the idea is that we are developing this code with three ideas in mind. Basically, that it needs to be accurate to produce accurate electromagnetic responses. This code needs to be flexible in order that the user can easily adapt to his necessities, and also that provide the electromagnetic responses in a feasible runtime. And for this last point, we are using high performance computing. We develop also this code in the open source license. And the idea is that now the last version and the last the version developed in the PIXIL project has support for active source electromagnetic method and for passive source electromagnetic method. And the idea is that this code is able to solve the Maxwell equation in frequency domain, and we have support for two of the main electromagnetic methods: the control source electromagnetic method that corresponds with the active source, and the magnetotelluric method that corresponds with the passive source electromagnetic method. So this is the background, a summary of the background that the code is able to solve, the equation that we are trying to solve. And the idea is that I'm going to present now three relevant cases that we developed using the PETCHEM code. The first one is the metallic borehole, a model with in the presence of a metallic borehole. The other one is the modeling using magnetotelluric method developed on the PIXIL project, and the other one is an ongoing work that corresponds with the Tenerife Island model. All these modeling cases have been developed and studied in the scope of the PIXIL project, and this PIXIL project allows us to work in a collaboration with other entities, not only with academy, with the University of Barcelona, of the BCAM, at the BSc, but also with the industry. That is the Geothermal solution that this part is a partner of the PIXIL project. So this is the summary of the outline, and for the I will start with the first test case. For the first test case corresponds with the Bayes model, and this model corresponds with the first experiment using PETCHEM for a geothermal energy context. The idea is that this Bayes region that is located on the northeast of Spain is relevant because several geothermal anomalies are present there. And the idea is that in the modeling was required to solve a resistivity model in the presence of a metallic borehole. The idea is that we have a resistivity model that corresponds, this is a general image, and we have the different resistivity, receivers receivers located in this line, the green point. But also the S3 point, that is a red point, corresponds with a metallic borehole that is located in the line, in line with the receivers. So the idea is that with this experiment, we need to study and understand which is the electromagnetic field pattern when this metallic structure is present. So how this metallic structure modify the electromagnetic responses. And this is relevant because in mostly modeling cases for geothermal energy modeling, there are a lot of metallic structures in that model. For instance, there are electrical networks, or there are other metallic structures like can affect the electromagnetic responses. So in conjunction with the University of Barcelona, we prepare the resistivity model for this case, and we design adapted measures for this kind of problem. The summary of the resistivity model that we are trying to solve, that we solve, corresponds with three materials: the air layer, that corresponds with the top layer, the blue layer, then a sediment layer that includes a topography, and the basement layer. Embedded, the challenge to design this tailored mesh corresponds to the inclusion of this small structure that simulate the presence of the metallic borehole. So with this mesh, we prepare different resistivity models, different resistivity values, and also we study different source configuration, different dipole configuration, the source that produce the electromagnetic field. So we study horizontal electrical dipole and vertical electrical dipole that are located on the top and the bottom of the metallic casing. The different values for these materials corresponds with this configuration. So basically, we design different resistivity values, and then we analyze which is the impact of the source direction, position, resistivity values, and also the dimension of the metallic borehole. And then we analyze different experiments trying to exploit the PETCHEM code capabilities. So there are a lot of numerical experiments and the derivative of these resistivity models. But the model that is marked on this red box corresponds with the most realistic configuration that we use to solve and to compare with experimental data. So by using this model as numerical solution, we compare the electromagnetic responses for this model, and then we compare with the experimental data provided by the UV team. And the idea is that with this comparison, we can validate the numerical results provided by the PETCHEM. This is the amplitude. This plot corresponds with the amplitude of the electromagnetic field, and we obtain an excellent agreement with the experimental data provided by the UV. The idea is that, and the main conclusion is that the metallic borehole influence and alter the electromagnetic field patterns in this way. Also, of course, it depends of the source configuration, it depends of the resistivity values, and also it depends of the configuration of the metallic case. But in general, this metallic structure can modify the electromagnetic responses, and in particular, this is quite interesting because it can alter the electromagnetic responses of these bodies or target located in the sediments of the basement. All results of this first step for geothermal energy context, for a geothermal application, are summarized on this paper that now is online, and it was the first adventure for geothermal energy modeling using the PETCHEM code. But in general, the conclusion is that we are able to solve this kind of problems in the geothermal energy modeling, in particular for dealing with complex topography, and also with modeling a small metallic structure located in the model. For the next main task developing of the PIXIL project is the development of an empty kernel. Initially, when the PIXIL project starts, the PETCHEM code only supports only was working with CSIN or active source modeling. So one of the main objectives in the PIXIL project was the development and implementation of an empty kernel. And basically, for this code development, we need collaborative work. We need to collaborate for the implementation, for the system integration, and also for the packing system. Now the main version of the code developed in the PIXIL project has support for active and passive source. And we also perform a refactoring task to adapt the code for this kind of problem. And thanks to the collaboration, we were able to understand the background, to implement the empty kernel, and we were able to simulate different and relevant scenarios of the magnetotelluric problem. The idea is that by using this verification, we were able to verify the robustness and the code capabilities to solve this new problem. This is a summary. This is an example of the model that we solved initially, and the Dublin test model that corresponds with the one of the most important of the basis benchmark that new developments are based to validate the robustness of the code. So this is the summary of the code. We have 3 different resistivity materials, and also it is embedded on the general on a hair model, on a half phase model. So this is the configuration of each resistivity value for each material, and you can see that there is a large conductivity contrast between them. So for this model, we compare the resistivity, the apparent resistivity, which is the main physical value for this kind of model, for the empty modeling, and we compare our electromagnetic responses against a well-established reference solution provided by the literature. For this case, we can see the different apparent resistivity modes for different periods of time, and the first column corresponds with the apparent resistivity, and the second, the right column corresponds with the phase of the electromagnetic responses. As you can see, we can obtain a good agreement for last period, but for early periods, we obtain we don't obtain a good agreement. But at this scale, and for the model proposed, for the proposed model, the early periods provide few information about the deep bodies. So basically, these discrepancies for early periods are also present for other reference and for other synthetic responses. So in general, we obtain a good agreement, and we validate that the code that working in a correct way. Also, we obtain excellent run times in comparison with the reference. In particular, the reference doesn't use high-performance computing; it's solved in a serial way. So this improvement radio in run times is because we are using high-performance computing. And also, we observe a positive impact of adapted meshes for each period. So the idea is that the number of degrees of freedom keeps constants, and also the run time for the solution of the problem keeps constant. So from the physical point of view, the code was validated by using this model, but also we studied the performance of the code. In general, we obtain excellent and competitive run times in comparison with other electromagnetic modeling. But of course, one of the main discriminators is the solver that we use to solve this problem. We are using parallel direct solvers, but also we can use iterative solver, but it depends of the the selection of the solver will impact in the solver convergence and also in the performance. But for this case that we use, we obtain an excellent, an acceptable speed up, an acceptable parallel efficiency for different basis order, since we are using and we have support for a different basis order in the finite element discretization. In general, the high order polynomials basis increase the runtime, but also offer better parallel efficiency radius than the low order. For instance, we have the red line corresponds with the first order, the linear basis order, and the green and the brown line corresponds with the high order basis. So in general, we have better parallel performance for high orders. And also, this is in this table, we summarize the efficiency for different number of cores and the runtime, speed up, and parallel efficiency for different basis order. In general, we obtain a better parallel efficiency for high orders. But of course, the conclusion of these experiments is that the computational efficiency of the code depends on the solver type and also on the input model. And this conclusion remains valid not only for MT modeling, but also for CSEM modeling. All results of this task, of this MT kernel, numerical experiments, physical behavior of the electromagnetic responses, and performance of the code has been summarized on this paper that now is also accepted and online in the Computer and Geosciences journal. So this is a good result for the project. And with these results, we now moving to the other challenging problem that corresponds with the Tenerife Island. The idea is that also in collaboration with the UV, we are working to try to understand the electromagnetic field patterns for this model that has a geothermal exploration interest since 18th. So basically this Tenerife Island located in Spain, by using this model, the UV has been provided a lot of empty responses. And then we are trying to solve by using the PETCHEM code. So with the help of the Tenerife Island, we are trying to build the resistivity model by using three different conceptual models in order to investigate the electromagnetic field patterns. An ocean model that includes the topography and the ocean of the model, the land model that only includes the topography but not the conductive surrounding model, and one simple 1D model that is the simplest case that doesn't have neither topography and neither ocean. So the idea for this collaboration is that based on this resistivity model, the UV proposed a low resistivity, a resistivity model for this Tenerife Island, and the geothermal energy reservoir or the geothermal energy system is characterized by a low resistivity layer. Low resistivity layer that corresponds with this layer in the green color, and identify other the low resistivity layer, the low to medium resistivity layer, and the medium to high resistivity layer. So the idea is that this is the conceptual model, and by using this conceptual model, we have four main layers: the high, the low, medium, and medium to high resistivity values by using this resistivity distribution. The idea is that for this geothermal system, that is now the challenge that we are working, is try to build the mesh and the model to perform the PETCHEM computation. Basically, the objective of this task is that we try to analyze not the empty and the CSEM responses, and to understand the Tenerife Island and the proof of knowledge about the Tenerife Island model. The idea is that we will use experimental data. We are using experimental data to build the computational domain. This experimental data has been provided by the UV. And the idea is that we need to migrate a finite difference grid to a finite element grid. by using an adapted of a tailored mesh approach. And then we will compare synthetic electromagnetic responses against experimental responses provided by the UV. The advantage that we have is that because the UV has the empty resources, we will able to verify and control and restrict the CSN responses provided by the PETCHEM. And we are working on that. This is an ongoing work, but this is our second or third adventure in the geothermal energy context developed again in the scope of the PIXIL project. Until now, we don't have a conclusion about this problem, but we are working on that. So we hope that before the end of the project, we will have results in this line. So as main conclusion, the idea is that the triple helix approach that we are proposing has a great potential for a geothermal energy context, in particular for a geothermal reservoir characterization by using adapted and tailored meshes, high performance computing, and electromagnetic methods. Thanks to the work development of the PIXIL project, now we have support for a full analysis of electromagnetic fields in 3D dimensions, and we are able to provide feasible runtimes, accurate electromagnetic responses, and high performance computing acceptable radius on that cluster. The idea is that also in the activity of this research line for the PIXIL, we try to transfer of knowledge developed or building in the scope of the oil and gas context, and now we are trying to transfer to geothermal energy. Basically, we identified two uses for the PETCHEM code that can be used for conventional and non-conventional, and also can be used for prior to drilling and after to drilling, depending on the stage of the exploration phase. And of course, this know-how is fundamental for future tasks, in particular for the development of inversion routines. And we confirm that the PETCHEM workflow can be suitable for many and different and diverse applications for oil and gas, geothermal energy, and maybe others. But of course, the idea is that for the solution of these problems, a multidisciplinary approach and collaboration is required in order to face the challenge that pose these physical problems. But the idea is that we are now in the situation that we are solving complex model, and thanks to the task and the work development of the PIXIL project, and also thanks to the support for other research centers and other research groups. But that's all for my part. If you have some question, I will be happy to talk with you. Thank you.
Thank you, Octavio. Do you have questions for Octavio? Octavio, maybe I missed something in your talk, but when you talk about you were talking about non-conventional scenario. What do you mean exactly?
Well, basically, the conventional scenario for this case corresponds with the oil and gas, with topography, isotropic or anisotropic modelings. And now for geothermal energy, it corresponds with the not conventional, basically because this is in a mature stage in comparison with oil and gas.
Mm-hmm. Okay, I mean, because for 3 or 5 years, so non-conventional had a different meaning, so that's why I was maybe confused by that, and maybe not a positive one. So it's maybe it would be good to make the difference between this energy and the other kind of non-conventional energy. is it only restricted to geothermal, or could this be applied to other kind of problem related to subsurface, for instance, CO2 capture, or sorry, not CO2, CO2, carbon. Yeah.
No, we can apply this strategy of this modeling strategy for other contexts. For instance, now we are trying to explore the application of water exploration, reservoir modeling of water reservoir characterization. Basically, it's the same physics. The idea is that we will receive a resistivity model, and then we are trying to analyze the electromagnetic responses, but focusing only for water prospection. That's the same idea. This is transversal. There are also applications for construction, maybe, and also for characterization of modeling at a minor scale. For instance, for installation of a geothermal station for a house.
Okay, thank you, Octavio. Other questions? Okay, so if there are no other questions, so I propose that we go to the last step of for today, which is a discussion on the talk that you see, and maybe also the potentiality for what we can do in the future using this result. So unfortunately, I'm not able to guess from the name of the participant who is an associate partner or not. So I know that Pierre Anques from Geode, unfortunately, won't be able to participate to the discussion now, but maybe other associate partner want to say something on what they saw on the topic that we consider. So maybe what I could ask you is, do you think you could use some of the results presented here? And the second question is that you see various topics, and maybe you feel we are missing something. So it is possible that one of the topic on mathematics or computer science necessary to tackle a geothermal problem is not in this project. So if you feel we are missing such a topic, we will be happy to have your opinion on this. So that's a lot of questions, so please feel free to participate. Does someone want to say something? Okay. So maybe we can also ask the people from the institution who did not talk today, because the talk was mainly centered on Action 3 meeting, but for instance, maybe someone from University of Barcelona can comment on the collaboration that you have with with the BSC.
Hello.
Hi, Pilar. Yes.
Well, I think PIXIL project works well, but probably we need more connection with the associate. I think, for example, today it's a pity because I don't see many partners associate. So perhaps we must learn from this experience, and in the next future, I don't know if there will be another Octesa project or not, but perhaps try at the very beginning of the project, ask the associate the needs, and try to answer their questions. So I think this is today is a pity because, for example, the people from Institute Geologic of Catalonia, they don't know there is the workshop, so perhaps there was a communicate problem. I don't know, but it's a question for us. Perhaps the project was okay. Well, we need to finish, and we did science. We tried to answer some mathematical problems, taking into account the data and also realistic models. But well, this is my opinion.
I agree with you. So thank you, Pilar, for this intervention. I think that one of the problems also that was not mentioned at the beginning is that we started this project just at the beginning of the COVID, and probably what we missed was a real physical event. And I think that this kind of events are very important for people to know each other and to strengthen the collaboration. That's probably one thing that we missed, but it was difficult to do otherwise. So I don't know if someone else wants to say something, or maybe from Geoplat or Pôle Avenia to have their opinion on the project and what could be improved if we are doing a next PIXIL, maybe not in the same format, but how can we continue this collaboration?
It's Emmanuel Robbins from Pôle Avenia. Can you hear me well?
Yes, we can hear you. Yes.
Well, for Pôle Avenia, it was a great opportunity to liaise with various people and so increase the relationship with our own members, actually, and also to enlarge the network that we have with the community, especially on the Spanish side. So for us, there is an interest to carry on the building up of this network, the community. And I wanted to take the opportunity to mention that we are going to organize the Geo Days mid-June this year in Pau. So that'll be the 14th and 15th. And the country that we want to push forward is actually Spain. So you are all welcome to the event. And we don't have the full details at the moment, but we're surely going to communicate more on that, and especially the website maybe in a month's time with the program. And I think it would be a good opportunity to meet again, or as a little meeting as a follow-up of this project, and maybe organize a side session to discuss the future of this PIXIL meeting.
Yes, and maybe we can hope that in June we can go physically to Pau. And this is open, so these geodays are open to all, so industrial, academics, and so.
It is often open to everybody. It's an international event, so we have people from all around the world, and the topics are all the topics from Pôle Avenia. And geothermal energy is one of them, but there's many other things, and I keep you posted on the program. And we are betting on an event, physical event, not visual.
Yeah.
Not even hybrid. We're going for the full physical event.
Okay, that's nice, because so I think I participated 2 years or 3 years before, and it was a very nice event, and So it goes from very applied topic to very theoretical. So there is a wide range of topic. It can be very interesting.
Yeah, we want to have some specific technical sessions, but also some networking. I was going to say event, but it's not event because it's part of the event. But we have some booths, we have some B2Bs, open innovation as well, which is anyone can submit a subject to big players. So previously we had Total, Storengy, Eramet, so it's open to everyone, and anyone can submit a subject to promote his topic and hopefully get financed by the bigger players.
Is there already a website or something?
Not yet, no. We are still building the program, and the website should be ready by the end of February. That's why I'm saying that I'm going to keep you posted, surely within the PIXIL consortium, but we're going to advertise via our LinkedIn account as well, and the website, Pôle Avenia website as well.
Yes, and we can also send an email to the participant of this of the workshop if they are interested, or maybe we can add. I don't know, Mireia, if it is too late to change the survey, but maybe we can add a question. So, do you want to have more information on Geo Energy Days so that we can collect the email and advertise after that?
Sure, I will add it.
Thank you. So thank you, Emmanuel, for your contribution. Does anybody wants to say something? So I don't know. Maybe someone from Geoplat could tell us what they think about this project, and if they would be interested to see a continuation of this project.
Hello.
Hello, Margarita.
Yes, we are very happy to have the chance to work with all of you. We think the results of the project are very useful for the geothermal community, even though some comments that were shared in this workshop were a little bit, I mean, not against geothermal, but I mean, not it's going to be easy to develop geothermal. I think all of you as scientists are at the, let's say, back part of the business. So what promoters and developers want is to get the results from your research, and your value is to let them know the amount of the resources they can't count on. So many steps we have to take in this decade, and projects as PIXIL can, of course, improve the development of geothermal in Spain and France. So it's been our pleasure.
Okay, thank you. So I also want to remind you that tomorrow we have a second day that could also bring a lot of information on what we can do now. So maybe it's a little bit soon now to discuss this, but I hope that we will have more answer tomorrow. So thank you, Margarita, for your contribution. And does someone want to say something more, or? otherwise, maybe Josep, a last word for a small conclusion of today, or?
So let's reconvene tomorrow.
Yes, I think that it's time to call it a day. And so tomorrow, the workshop will start at 9 o'clock. There will be talk about geothermal energy in France, in Spain, and then in Western Switzerland. So an overview of geothermal energy in 3 countries. And then after the break, there will be two topics that we thought could be interesting in view of a future of PIXIL. The first one is a targeting tool for having some kind of cartography of the Pyrenees, and also which aim as using lithium as a byproduct. So we should not forget that with geothermal resources, there is often lithium associated to it. And it was interesting to discuss this point tomorrow. And the second talk will be the Club Saumur, which is an association. So maybe the term association is not good. So Romain Millot will present it more in detail tomorrow. And what we thought interesting is the way of collaborating that was inside this Club Saumur. Then we will have a talk of Marc Blaizot on a project that is called PIXIL, which is also a transborder project. It's a large industrial transborder project, and maybe it could also give us some idea on how we can continue the collaboration. And finally, we will have a talk of Jean-Louis Valls about that we will present the CTP, which is a community of work in the Pyrenees. So I'm not sure of the English translation actually. So we will also talk about transborder cooperation. So if you can assist tomorrow, you are very welcome. It will start at 9 and hope it will end around noon, I think. So I thank you. I thank all the participants for the workshop. I thank the interpreters for their work. It's not easy to do this remotely. And so I hope to see you all tomorrow on the same channel. Okay, so thank you very much, and have a nice afternoon. Okay, so maybe we can start, Jean-Jacques, when you want. Okay, thank you very much for participating to the workshop. And sorry, maybe I should introduce you. So the first talk is from Jean-Jacques Graff from AFPG, and he will talk about deep geothermal energy market in France. So when you want, Jean-Jacques.
Thank you, Julien. Do you hear me good? Do you see my presentation? It's
yes,
okay.
Everything is okay. Yes.
Good morning, everybody. I'm very happy to be here, and also I'm happy to start this PIXIL workshop this morning. I will give you a short overview of the deep geothermal energy market in France. I'll try to. Okay. The data I will speak coming from this market study we did last year. We published it last September. You can find it on our website, afpg.asso.fr. And you can have an update of the market, of the deep geothermal market, but also on the shallow geothermal energy market. It's in French, but we made a summary in English. Today I will make a focus on deep geothermal energy. I will speak about heat production, power production, a bit about lithium production, and also I will give you some perspectives of the market. We discussed last weeks with the Ministry of Ecology how to improve the geothermal energy in the next years. And this discussion included in the PPE, it's Programmation Pluriannuelle de l'Énergie, it's pluriannual energy programmation. And so I will give you some conclusion of the discussion. We did this market study with our partner ADEME, the French Environment and Energy Management Agency, also with BRGM, the Geological and Mining Bureau, and finally with the Syndicat des Énergies Renouvelables, is the Renewable Energy Union. First slide about our experience in France. We have more than 120 geothermal wells drilled. Down the maximal is 2.5 kilometers in the Paris area. These wells were drilled mainly in the Doguer, but also some wells were drilled in the Trias and in the Abia on the top reservoir. The first drilling, first wells, we started it in 1969. We have a long time experience, and currently we have 57 plants in operation, mostly for heating and also sanitary hot water, would distribute to around 1 million inhabitants. What is a situation in deep geothermal energy for heat? And we have currently a production of near 2.5 terawatt hour, but the main part are coming from the Parisian basin with approximately 2 terawatt hours per year. And we have also a short production in the southwest, where you are, most of you, and with 160,000 megawatt hour per year. And in the other region, we have a bit more than 230,000 megawatt hour per year. But as you can see, the main part are coming from Ecology in Rittershofen, deep geothermal heat plant dedicated to industry, and they are near 200 gigawatt hour per year. It's a big part of the other region. Can you give some distribution? As you can see below, the main part of the heat is dedicated to district heating networks. As another part, 8% for industrial heat, and small part, 3% to greenhouses and fish farming, and the last 2% to swimming pools and spa. What are the perspectives for the next years? As you can see, from 2005 to 2020, it's increasing from 1 terawatt hour per year to 2.5 terawatt hour. And the objective for 2023 is between 2.9 to 4.6, and as a trajectory for the next years, 2028, are between 4 and 5.2. And ministries asked us also to make a projection to 2033, and we expected to have a range from 6.7 to 8.3 terawatt hours per year. But to reach this objective, we need to have some new tools to develop very strongly geothermal energy. In the renewable heat, currently you have only 4% of geothermal energy production. So we have a very good reservoir for renewable heat in geothermal, but we need to develop it. And how to develop this heat production? We proposed more actions, and to reach this 2033 objective. First action is to increase significantly the Fonds Chaleur tool. As you know, perhaps it's an investment subsidy mechanism. Currently, we have 300 million euro, but we asked to make 3 times the amount and to reach per year 1 billion euro. And we compared it to the intensive for renewable feed-in tariff. We have currently near between 5 to 6 billion euro per year. That it's a real discrimination. And we ask strongly to increase this amount. We know it's the best tool to increase the geothermal energy. As you know, geothermal energy is a long-term investment. You need to wait 8-10 years because before to have the return of the investment. And so with such tools, you can reduce this time to 5-6 years, and so we can do projects with this. Another proposal is the extension of the geological risk guarantee. Currently, we have a risk guarantee only on the Parisian Basin, and in the Parisian Basin only on the Dogger. And we have some 5-6 projects out of the Parisian Basin, but it's very rare. And we worked with ADEME, with BCAM, and other partners to develop this tool to have the possibility to go out of the Parisian Basin. And we wrote a tool for 70 heat plants on the next 10 years. And this mechanism is under EC notification. So we hope we will have it end of this year. We ask also to keep a reduced VAT rate from 5.5% for district heating, with more than 50% of renewable energy. And also we ask, this exists, but we ask to keep it. And we ask a new extension for district cooling grids. As you know, we have a real demand on the district cooling grids currently with the hot summers. It could be very interesting. We also ask the ministries to reduce the permits instruction time. Last year, we can expect to 1 year instruction, but mainly as you need to wait 2 years for the instruction of the dossier. And so we compare to Germany. To Germany, they need to from 7 months to 1 year for the instruction. So we ask to make a strong reinforcement of the people on the ministry for the instruction of the dossier. And we also ask for to keep innovation support, to try a new way to develop geothermal energy, like bigger diameter drillings, composite casing to avoid corrosion. It's a very good thing to reduce the OPEX. And also when we reach some aquifer with a low temperature, we propose also some support to develop large scale heat pumps, and also for technology like multi-drain technology to improve the flow rate, like the same for sub-horizontal drilling. And a very important tool, the next proposal is to work for new guarantee tools for industrial and agribusiness uses. And we discussed this with EJEC, Philippe Dumas, and as he says, it probably will be included to the next RED 3 recommendation. It's a heat purchase agreement to secure projects, so investors could start projects with a safety tool to avoid to minimize the risk, investment risk. And also we ask about what kind of tax to reach the 2050 carbon neutrality. It's a huge challenge, and we are convinced that geothermal energy could be one of the biggest tool to attempt this objective. And so it could be also interesting to discuss about a new tax, but as you see, the gas price, the oil price are very high currently, so it's for us it's a good news. And I will speak about now electricity production. We have in France a lot of exploration permits in France mainland, in Massif Central, in the southwest part of France, in the Rhine Graben also a lot of permits are asked, in the Rhone Graben, and also in overseas like Guadeloupe, Martinique, La Réunion, Mayotte. We have near 7 permits under instruction. And what is the situation currently for electricity production by geothermal energy? We have in the mainland 1.5 megawatt installed at Souls. It's a demonstrator. It's a pilot project, so it's not very significant. But we learned a lot about with this pilot project. And we have near 20 megawatt installed at Guadeloupe Island. And in the overseas, they can negotiate the feed-in tariff directly with the government. It's not a global feed-in tariff doesn't exist for the overseas, so you negotiate directly. And as I mentioned it, we have 7 exploration permits ongoing. And as you know, perhaps the government stopped the feed-in tariff for France mainland for new projects, but they keep a project with eligibility. So we had a special feed-in tariff from 246 euro per megawatt hour. It's a very interesting price, but it's maintained for approximately some 10-12 projects for a pipe, a maximum production of 57 megawatt electricity. And also an important news is the project around Strasbourg were stopped due to seismic activities is in north of Strasbourg. It started end of 2019. Currently, we don't know if it's natural activity or induced, but in end of September, October 2020, we had a lot of induced seismicity activities, also stopped the project. And the ministry created a special ministerial working group to define new recommendations for mastering seismic events. We will have in the mid of this year, we will have a new recommendation and how to master it. But the people from ministry said that they don't want to stop geothermal energy, but they want to make milestones and to be sure that the operator will use the best tools for each step. And in the French Geothermal Association, AFPG, we also started a working group about seismicity. And we worked together with EGEC, European Geothermal Energy Council, and some European operators coming from Germany, from Switzerland, from Belgium, from United Kingdom. So we can have also a good knowledge. We saw that the seismic matter are very important in each country of Europe. And the objective is to write also recommendation, more technical recommendation to write the best practices. And Minister of Ecology, Barbara Pompili, said we need to give this recommendation to the ministerial working group, that we will do it on next February. And also the situation of the extraction of lithium. As you know, in some graben, you have very lot of lithium in geothermal water, near 200 microgram per liter. It's very huge when you circulate with a flow rate of 300 cubic meter per hour during 8,000 hours a year. It's a huge amount of lithium. And Eramet with Électricité de Strasbourg and BCAM tested a pilot project to extract lithium, and it's in Sulz and Rittershofen, and it's a real success. They reached to extract lithium during circulation, and it's a very good news for the next for a new development for geothermal energy. And we currently have 3 lithium permits under instruction in the Rhine Graben, but also in Massif Central in the center of France. What we proposed for the next year for this electricity production by geothermal energy, we propose and we work since last year, beginning of last year, on a geological guarantee tools also, like the same like the Parisian Basin for heat. And it could be also interesting to have such a tool for the overseas islands. And for the pipe of 57 megawatt accorded by the EC, we propose to work together to reduce capex, to reduce opex, to master, very important, to master seismic events, and also to analyze a new economic balance between power production, electricity production, heat co-production. As you know, with you have a lot of fatal heat when you produce electricity, but the fatal heat is a temperature with a very low temperature, and 30 degree, for example, but you can do a lot with 30 degrees. So we propose to work also on this topic, heat co-production, and also lithium extraction. We need to see how it could be interesting with power production, heat production, and lithium production with the same plant. And also we asked a strong support for R&D for lithium extraction. It's very strategic. In Germany, you have a lot of investors working on this topic. It's crucial for the next years with batteries. You need a lot of lithium. You have more demands than possibility to produce lithium. So it's very strategic, and French government are aware that it's a very interesting topic, and they will put a lot of money for this. And we propose also before 2028 to propose a new feed-in tariff, including the new balance with heat co-production and lithium extraction. With the first simulation, we think we could reach a tariff less than 100 euro per megawatt hour. It could be in the range of electricity production by renewable energy. That's all for this presentation. Thank you very much.
Thank you very much. Sorry, I had to switch between the channels, so I had some delay. So thank you very much for this very nice talk, and it gave a good overview of geothermal energy in France. And I think that we will talk about lithium in the next in other talks of the morning. So it's really an interesting topic for me. So I saw that Jean-Claude has put his camera on, so maybe you want to ask a question. Yeah.
Indeed, yes. Thank you, Jean-Jacques. Yeah, nice talk. So I'm from Real-Time Seismic company. I have a question about, you mentioned about a kind of guideline or a chart for seismicity. Can you tell us more about the calendar? When is it going to be published? Do we know a little bit about the content of these recommendations? Can you tell us more about that?
But we made a very strong return of experience. What happened in Souls at the time in 2003. I came at the time at Souls as manager, as co-manager to master these events. It was the case in 2003. It's not a recent topic, and we have a good knowledge about Souls. But at the time they worked on hot dry rock technology, so they wanted to frack. And we also have good data from Forge in the project in Vendenheim in the north of Strasbourg, and we try to understand what happened. And it seems to be clear that both wells are very, very bad connected. That is the main problem. So that also give us ideas like an obligation to do 3D seismic to have a good view of the reservoir. And at Souls I had the same problem at the time. Wells, the 3 wells was not very good connected, and we had a problem. And so it's one lesson, and we worked on three topics. And the first topic was exploration, drilling, and the test, circulation test, and well testing. And that it's the first working group. And another one to work on tools. What kind of tools, predictive tools to see how we can master these events. And the second workshop was dedicated to communication. It's also a main topic. It was the project of Forge was on an industrial way, and they made a very less presentation for publics and so on. And it's important also to have good communication tools to be transparent, and that's also a main topic. I saw a project in Switzerland, like in St. Gallen. They had also seismic problems, but they had a very good communication with the public, and they had absolutely no disaster when the events were started. And I think we have a lot of lessons also to learn about communication. So we worked on different groups, and we realized the first draft, and we will discuss it next week internal in AFPG. And we think we can produce it mid or end of February to the ministry, and we also can share it to Pôle Avenia and other partners. And we worked with Pôle Avenia also on this topic. Pôle Avenia and the companies working under the umbrella of Pôle Avenia, and so the idea is to share. It's very important say that to the government to share the knowledge. It's not possible to work alone, and the geothermal market is in the philosophy as they work a lot alone, and I think we have a lot of things to learn to oil and gas market. When they are competitors, but they can say companies can also work together and share the problems. So it's that I think we need to make some improvement in the geothermal field.
Thank you.
Thank you, Jean-Jacques. Are there other questions? So yes.
So if there is no other questions, well, to continue the discussion, in terms of geomechanics, was there an action? I mean, do you plan to have geomechanics models to be studied upfront and then updated during the critical phases of the drilling and the injection? Was that part of the arsenal of means to put in place?
Sorry, I'm not involved in this topic, so I cannot give you an answer about that. But
I was talking about geomechanics.
Yeah, but we work on the return of experience. What happened in Rittersofen with the different stimulation, thermal stimulation, chemical stimulation, and also hydraulic injection, step by step. That it's also we have a good experience with this, a good knowledge. But I cannot give you more data about that. But I propose also you can. I don't know your statute. If you are working with Pôle Avenia, you can also come to the working group and to give your advice about that.
Thank you.
Okay, thank you. So I had one question on communication, but you already answered it in your first answer. So are there other questions for Jean-Jacques?
Yeah, from my side, Jerôme Chablais from Hydro-Géo. Thank you, Mr. Graff. It's a nice presentation. Now, just a quick question about the innovation support and large-scale heat pumps, which I think is really nice because in Switzerland, we currently, you will see later, have some financial support, and they really focus on the direct use of heat. And if you are below a certain temperature and you need some heat pumps, they just stop the financial support, which is a bit a pity for my opinion, because you have to fit your geothermal project with also your reality, where is your resources and where it's a good one. And I think it's really nice to see that. My question is about your innovation support. You are at a certain steps where you try to motivate the government to support adding of heat pumps, or it's already in the pipe, it's accepted?
Maybe it's accepted. We have some projects in Paris with reservoir like Albion. You have 30 to 50 degrees. It's not enough for district heating. So we have heat pumps, but the target is to have more such a project. And so if it's interesting to develop tools, incentive tools, innovation tools for heat pumps, for large scale heat pumps, it could be a proposal. It's an idea. It's coming from a brainstorming, but the model we have not a specific model. It could be Fonchaleur incentives, but also it's possible to develop to make some innovations or R&D on this topic, or it's very good industrialized. I don't know, but it's a way. But we see a lot of reservoir, low temperature reservoir, and it could be very interesting to use it, but with heat pumps.
Oh, thank you. It's the same in Switzerland, and I want to move forward in this way, so it can be good to be in contact and exchange also to interact. Thanks a lot.
Okay. Thank you. We have time for one last question if someone wants. No? Okay, we already had a lot of questions anyway. So thank you, Jean-Jacques, once again.
Thank you.
Maybe we can move to the next talk from Javier Urchueguía from Geoplat, I think. And so he will present also the geothermal energy in Spain. So Javier, can you share your slides, please?
Okay, I will try.
Yes.
Can you hear me well?
Very well.
Okay, excellent. So I will try to share my screen. This is always tricky. Okay, here it is. Yes. So I think you should be able now to see my presentation.
Yeah, yes, so it's not full screen. I don't know if you can.
Is it now?
Yes.
Excellent.
Perfect.
Okay, good morning, everyone. Good morning, everyone. My name is Javier Urchueguía. I am professor at the Universidad Politécnica de Valencia, and also involved in several activities at European level, and including also Geoplat. Geoplat is the Spanish geothermal association or platform, better to say. It's a research and innovation platform, and I have the honor today to try to give you a vision about the geothermal sector in Spain, how it has evolved in the last let's say 20 years in the shallow geothermal part, or even before, for deep geothermal. I'm not expert in deep geothermal, but we have here some colleagues like Celestino, Margarita, which also belong to Geoplat, and I'm sure they can perhaps at the end of my talk give some indication, some extra information about the deep geothermal sector. There are some news about this, some installations. Anyway, this is not my area of expertise, so I will talk mainly about shallow geothermal, and about what are the trends in Spain, what is the situation of the sector, what are the data, the latest data, and also a brief outlook of why Spain it's looking with more and more interest at shallow geothermal as a possible tool for decarbonizing the heating and cooling sector. So just this is a view from EGC. I belong also to EJEC, so we have general data about what are in Europe, at least let's say the main areas of use of geothermal energy. So here we can see that even looking at Europe as a whole, shallow geothermal is still dominating. Is 2/3 of the market, of the production of geothermal energy. In Spain, it is, I would say, even more pregnant. Let's say the shallow geothermal has had quite a development in the last 20 years, I would say, whilst direct uses, and there is no electricity to my knowledge, and direct uses have been stagnating in the last decades. Although there were some direct uses, traditional direct uses in the past. So I think Celestino perhaps or Margarita will have more to say about that at the end of my talk. So here, going to the shallow geothermal market here, again, in a European vision, you can see here that, well, Spain appears here as a little part of the market. Here we can see some projections which were made in the EGC from 2019, which by the way was done which was in France. So we can see here what was expected in the different countries in Europe in terms of installed capacity in megawatts, you can see, and according to different times here, what was expected in 2013, then the capacity added till 2016, you can see here in red, and then 2019, and this is a good indication of how the market is growing in the different countries here, and what was expected in 2020. which I have noted, not the updated data till now. So here you can see that those countries, well, which have more installed capacity are those that are growing faster. But in Spain, there is still some growth here, as you can see. And I will talk later about more updated data, which we have now. I can give you some new insight into the reality of the shallow geothermal sector in Spain. So we are not an important country in shallow geothermal in Europe, as you can see here from this data. And but there is a promising, let's say, evolution towards an increase in capacity. So in Europe, we have, these are the big numbers here. We have in the shallow geothermal about 30,000 megawatt thermal megawatt installed, and more than 2 million units, with a growth of about 100,000 each year. This would be the situation in Spain. We have no electricity, as I was saying. The total capacity, I will talk later about this, was estimated from us to be about 500, a little bit less than 500 megawatt thermal. And there was also, let's say, in the recent past, no clear numbers about what's the number of ground source heat pump units installed in our country. In a moment, I will give a new insight about that and an update of this data, but also discuss some of the problems we had in collecting this type of information, which is quite important to understand what is the situation in the market. So, in general terms, we can be satisfied that 20 years ago there was no geothermal in Spain, at least in the shallow geothermal part. And much has been accomplished, but we can say that this is not enough. What has been accomplished, we have a much larger potential. Spain is a very important market in heat pumps in Europe, and still most of them are air source heat pump. So what are the cons? What are the reasons why this is not, let's say, more satisfactory in our country? The first of all is like lack of awareness. Especially in the building sector, still there are most architects that do not have any awareness about the possibilities that geothermal energy is offering. So this is especially also true because of this lack of number of statistics, so of data. So there was a huge problems in really being able to collect or to give, let's say, a coherent picture of what is the number of installation. We have in Spain many, let's say, many institutions, regional institutions that are in charge of the regional energy policy. So there is some, let's say, lack of central policy in this case. This brings me to the next point. We lack a clear and homogeneous support framework from the policymaker or from the funding perspective. Till now, the energy policy has not perceived the thermal sector in general, and the geothermal sector in particular, as a strategic component of the energy sector. And it has traditionally been also always associated to electricity, and in the renewable and case, particularly with photovoltaics, with wind, in which Spain is a country with a lot of development, but the geothermal has not so been perceived by policy in such a way. So, despite there are many institutions that are more and more aware, and we have, for instance, in Geoplat, we have IDAE, which is a main institution in Spain for energy policy. This has worked more at the technical level, but perhaps not so much as at the level of policy and perception from the public institutions. We are in a somewhat, I would call here, a regulatory nowhere's land. There was no specific regulations for shallow geothermal in Spain. There are regulations regarding security or safety. There are regulations regarding water, but there is no framework which is operating at country level, and this is always also a clear barrier, specifically if you go to the local level, to the municipalities, which can or may have their own things to say about where geothermal can be deployed or not. So this is also a huge barrier. We have been in Geoplat working with several institutions to, let's say, to to have more awareness about the need for such clearer regulations. And this also brings us to this, which is a general problem in Europe. In Spain, let's say there is this specific imbalance because of the wide availability of gas for thermal uses in the country. So these gas prices till now have not reflected the environmental costs associated to this production or to distribution of gas. So there's an unfair competition here clearly with the heat pumps, with the shallow geothermal energy, which also has been, let's say, a part of the big problem in the market. Well, not everything is so, let's say, so pessimistic. I would say we have done a lot in the last 20 years, and I would also speak about positive evolutions in Spain, about the pros. First of all, I think we have a complete value chain. We have experienced people. There are many installations, as we will see, and even many of them are installations with quite a lot of technology. And for instance, there are even district heating systems operating with geothermal energy. Spain was specifically much focused also on using geothermal or shallow geothermal heat pumps for cooling. And this was a specificity in our market. And this brings us also to larger installations than which is the average value in the rest of Europe. Our average value is 52 kilowatt for let's say for a unit installation. And this is much larger. These are regular or normally much more complex installations, which have more technology. There are also many hybrid systems, air source, ground source heat pump. And so I would say there is experience in the market. There are also experience in influential stakeholders, like for instance, Geoplat, but many others that are interested in geothermal. These larger systems bring us also to more and more awareness in some of the public institutions. For instance, many of the installations are public installations, and this, let's say, have brought to more and more interest in the public stakeholders. There are a lot of involvement of R&D. Let's say Spain or Spanish stakeholders, Spanish universities, institutes are in many European projects in many areas, even in deep geothermal, in many areas of shallow geothermal or deep geothermal research. We have also the ICME. ICME is a central institution in Spain for Instituto Geominero or Geomining Institute, which, like IDAE, have a central role really in involving the R&D chain or value chain also in this type of research. And we have an advanced framework, I would say a very good framework, conditions for training of professionals, for training of engineers. We have here GeoTrinet courses since 2012, let's say organized by Geoplat. We have also in Spain the first, to my knowledge, professional course according to the REST directive, or really answering to the REST directive request for training of professionals in level 2 and level 3, which was recently released by the ministry in collaboration with Geoplat and other institutions in Spain, like INCUAL. So I think we have good framework conditions for training people, for having quality in the installations. We have already many of them. We have a value chain. And I think this is a favorable situation to have a growing market in our country. We have also a recognized standard. UNE was in 2013 a group of stakeholders in Spain who developed a known standard for quality of installations, which is widely recognized among institutions and clients along the country. So I think these got good conditions to start, let's say, to grow in the market. So towards 2030, what could be the picture? What is the, let's say, the update of our evolution in Spain here? One of the complaints we had traditionally was the lack of data. As I said before, it is difficult to take decisions if you don't have a picture of the reality. So we have been working with IDAE, which I said IDAE is the Spanish Institute for Energy Diversification in Spanish, and it's a core member of Geoplat. And after a lot of work, there have been news. We have now quite complete, let's say, update with a new methodology on how to what is the situation of the shallow geothermal market in Spain. So here, this is the link, and I've been, let's say, the study is quite new, and I think they want to present it in the next day. So this is really a new information, and I will just, with the permission of IDAE, give you some highlights about the numbers of the evolution in the last years of the shallow geothermal market in Spain. Here you can see in 3 colors the different years here from 2014 to 2020. Potencia thermica is the capacity, the installed capacity, which according to this is about 180 to 200 megawatts, sorry, installed. Here I must say that one of the shortcomings of this study is that it's not complete, because it was a questionnaire sent to different regions, and to my knowledge, not everyone answered, and perhaps many of the installations are not included in the study. But at least this gives you a temporal picture on how the market is evolving here. So what you can see here clearly is that from the point of view of number of installations and capacity installed, from 100,000 to 100 megawatts to 180, there has been quite a growth, quite an evolution in the last years. Probably the installed capacity is considerably larger, but here you can see that there is at least a trend for growth. The same is for the electric consumption and the thermal production and the number of plants. The number of plants is of the order of 3,000. Here the number is difficult to see, 3,000, 4,000. Although I must say that, let's say, if you compare it to European values, in Europe, the average installation is about 12 kilowatt. Here, which you can do easily the calculation, the average capacity is about 52 kilowatts for a single installation or unit. So this means that, let's say, in European equivalent, we would have about 12,000 installations if you compare its equal power capacity. An interesting figure is this one here in the upper part. One thing you can see is the SPF, the efficiency of these installations have been growing here. We have now an average SPF of about 5, almost 5. And this is an interesting figure because it highlights the fact that these installations are working with quite a high capacity, with quite a high efficiency in Spain. So this also points to the fact that most of them are, let's say, technologically sound and well installed and well operating. So just to conclude a little bit with Geoplat, what is the role of Geoplat or such stakeholders here? Geoplat is a Spanish association or platform for geothermal. You can see here that it includes entities like companies, universities, or such important stakeholders like CIEMAT, IDAE, which is really core to have this access to the, let's say, to the core institutional policy and let's say stakeholders. It is important to say that we have been really actively since 2009 pursuing to increase R&D in geothermal energy, but also to try to streamline policy in a much more, let's say, fair way for geothermal energy, also in the field of deep geothermal. So I would like to Celestino or Margarito to make perhaps some comment about deep geothermal evolution in our country. So for our final consideration, just to conclude, let's say the evolution in the Spanish market is encouraging. We have a lot of experience in shallow geothermal, we can say now, but there are still many things to do in the area of regulation, in the area of market conditions. Let's say the situation now with the energy transition has put geothermal in the focus of Spanish policy, and particularly geothermal is viewed now as a very interesting option for such things as, or such key concepts that we could say that are sector coupling. First of all, sector coupling is the, let's say, the interface between the electric and the thermal sector, in which by its nature, shallow geothermal can play a very, very interesting role. heat pumps are electric devices and also thermal devices, and they are ideal for performing sector coupling policy. It's also interesting to highlight that the perception in the ministry or in the institutions is more and more that shallow geothermal is a highly efficient way, let's say, energy source, and this is demonstrated by the numbers I just reported with a SPF of almost 5, which is, I think, a very interesting position. Also, there is an interesting thing to say, or very strategic thing to awareness here, that for the cooling demand, there is really there are really not many options in the renewable energy, let's say, portfolio. So geothermal for let's say for a high energy or cooling demand buildings is really one of the only ways to go. So this is also perceived more and more in our country. There are also district heating systems with cooling, which are really interesting in Spain. And the last comment here, it's the perception of the energy dependency. In Spain, the energy dependency is particularly, let's say, real. We have more than 80% of imports, and this is also particularly linked to the thermal sector. So the question that, or the fact that geothermal is linked to your ground, it's under your feet, it's also an important message for policymakers, which shall help us to really push our sector in the way we would wish. So this is all for my side. Thank you very much for your attention. I would like Celestino or perhaps Margarita to make some additional comments about the situation of the deep geothermal in our country.
Okay. Thank you very much, Javier. So as Javier proposed, if Margarita or Celestino wants to participate, feel free to open your microphone.
Good morning.
Good morning,
Thank you, Javier, for this extraordinary presentation, this vision of our sector. And regarding geothermal, deep geothermal energy or power geothermal in Spain, now we are, let's say, at the beginning of a very promising decade. There are some news, especially regarding the islands. So in the Canary Islands, there are some permits that have been asked for very big utility companies in Spain, and there are as well some developments in the mainland as well, in the south of Spain. So we really hope this decade brings us at least the first geothermal power plant in Spain. And yes, the sector is working hard to get it, and very close to our ministry, the Ecologic Transition Ministry as well. So we are trying to set the conditions to have the first geothermal project power plants in Spain in this decade. So this is mainly the information.
Okay, thank you, Margarita. So thank you, Javier, for this talk. Very interesting also to see what happens in Spain. So do you have questions for Javier or Margarita? I have one question, but so it's maybe also for Jean-Jacques, because so we have some people trying to promote geothermal energy in Spain, other one in France. Are there some kind of coordinated effort for the European Union, so to try to promote this energy at the European level?
France for us is an example, a very good example. So it's like a very good mirror. So the development of geothermal in France for us is a dream, you know, so we dream of that development, to have that development in Spain, even though that can be, as Jean-Jacques let us know, can be improved. But when we see those feed-in tariffs, those risk mitigation systems, the district heating network, geothermal district heating that they have in France. So all of that for us is just what we want to have and developed in Spain as well. So for us is a very good example. And of course, we are collaborating in and working together in the European Geothermal Association. So we think the joint of effort in Mediterranean countries is a key for developing geothermal, especially, for example, if you think in cooling, because sometimes we have difficulties to promoting cooling in the European Union, to get support to cooling, you know, policies and any other schemes to support cooling and to promote cooling. And Mediterranean countries, we have more need of cooling than other European countries. So in those terms, there is a question now. So our synergies and joint effort can be very profitable and useful for the sector. There is a question about the permits.
Yes, maybe I can read it. So for the people who I don't know for the recording how it's going, so I will read it. What are the administrative procedures in Spain to get a geothermal permit? Is it long to get it? From Marc Blaizot.
I understand Marc is asking about permits to develop deep geothermal, right?
Yes, can you confirm, Marc?
Right, exactly.
Yes.
Thank you, Margarita, to take the question.
We have a law, the mining law in Spain is pre-constitutional. So it was published before we are a democracy, yes. So we start our democracy in Spain in the year that I was born, in 1978.
You are too young.
The law was published before the Constitution. So, as you can understand, for this fact is, let's say, in some points a little bit old-fashioned. So, the development of the geothermal permits procedure was established in that law, and we can say, in order to give you like a brief and fast information, it is similar to the mining permit, you know, the procedure. So you have to ask for a big squares. I don't know the technical name in English. In Spanish, we call cuadrículas for exploration. And so it takes time, but especially in terms of environmental issues. We have in Spain now the situation regarding environment and territorial aspects and renewable energies in general is a little bit now boiling, let's say. So civil society now is worried because we have now promoters developing very big solar and wind projects in the empty Spain. So people from the empty Spain is not very in favor. So that situation affects as well to other renewables. So that's why the importance to get the social licensing for the project is going to be essential as well to develop these geothermal power plants in Spain. So in terms of time, maybe the environmental aspects can be the more critical for this kind of projects.
Okay, thank you, Margarita.
My pleasure.
So we have time for one last question, if someone wants. No. Okay, so thank you once again, Javier and Margarita, for this presentation. It was very nice. So now, we have seen geothermal energy in France, then in Spain. So now it's we will have a presentation on Western Switzerland from Jerôme Chablais. He is from Hydro-Géo Environnement. Jerôme, can you share your slide?
Yes, let's do that.
Yes, and so just one question: can you see my video?
Yeah.
Yes, because I have a complete black screen, so probably I will disconnect and come back. But I will first introduce your talk, and then I will try to fix this. So Jerôme, I cannot read the title of your presentation, but I let you start, and I will.
Do you see the presentation in diaporama?
Yes, very well.
I don't, but it's really from my side.
Thank you.
So I think that everybody.
Okie doke.
Yeah, it's fine. We see it.
Thank you.
Yes, thank you.
So, thanks.
So you can start.
So, yeah, thank you. So thank you for the invitation. So maybe my talk, you will see it's a bit more geoscientific, not more about production values and rate. So, but let's start. The idea was to present you our current state of let's say exploration project in Switzerland. So, but Julian, just introduce myself very quickly, because maybe nobody know me or our company, but we are let's say small company, geoscientific company based in Geneva, with one branch in other canton of Switzerland. So we are mostly working in the French part of Switzerland, which is the main focus of our talk today. And we are about 25 collaborators, mostly working in geothermal project now, with covering all aspects of geothermal needs in terms of geosciences, geology, hydrogeology, reservoir engineering, drilling engineering as well. So let's switch first to the current project location. So in Switzerland, we are more on the steps now on the exploration approach. So especially for the mid-deep geothermal project, we are not a country with a strong, let's say, oil and gas history or exploration history. So we cannot compare, for example, a country like the Paris Basin, where you have a lot of wells, and you started to develop your thermal project with a good understanding view of your subsurface. So we are quite blind, let's say. So that's why we are really at the beginning, also at very exciting decades for especially mid-deep geothermal project for its purpose, as you will see. But today, this is a picture of geothermal in Switzerland. So most of the project, as you can see with the circle, are for its purpose. And the one for electricity is very rare. We had some tested one in Basel, but with an earthquake issue, as I think you know. Also some in close to St. Gallen as well. It was a mix also for aid production. And today, yes, we have one new project starting next week in the area. I don't see if you see my mouse. Not, but in the area.
We do.
Yeah,
we do.
Perfect. See here. So we have next week, after, let's say, 10 years, not to say 15 years, planification and project management, we start this new project of AGEP in the area of between the canton of Vaud and Valais. It's an electrical project drilling up to 3,000 meters deep. And this summer we will start this project Vinzel, which is a heat project. So the number of projects you can see, especially the one in green in operation, is that can be a bit confused because it's more about geothermal bath, swimming pool project. It's not for really heat, but it has been mixed like that by the Confederation. This is a map coming from the Swiss Topo, the one dealing with the database in Switzerland, but it gives you a little, at least an overview of the ongoing project. So we will go more deeper in this part of Switzerland. And as you can see, if you see what kind of project we need to develop in Switzerland, it's more about heat project. Why? Simply due to the location of our resources in terms of subsurface, where we deal with aquifers between 1,000 meters deep to 3,000 meters deep. I will not speak today about the shallow geothermal project, which is well developed in Switzerland. We have a lot of geothermal probes project. It's something which is really continuous since at least 10 years. And this is an important, of course, input for heat in Switzerland. But now we enter into these decades to move forward on mid-deep geothermal project to find resources located between these depth interval. And in parallel, of course, the need of electricity. But this is less developed due to the location of our resources, the complexity, the risk of earthquake. So it is a requirement, a need, but it will take time. So let's focus here and finally to understand what are our approach to develop such kind of project, and why let's say it is important. As you can see here, it's a summary of our need in Switzerland. So it's a study done recently. I don't detail, excuse me, the result of the study, but I really let's say encourage you to go to visit this website, this page, where you have access to the full report, and it will give you a good hint of the actual projection, actual requirement in terms of heat and also in terms of electricity. This study covers also all the aspects of the shallow geothermal potential and need, and this is related to the strategy of energy from Switzerland. So it's quite aggressive. It means that to cover such part of production, we will need to develop a lot of our geothermal plants for mid-deep project and deep ones, so for heat and electricity. But you see in summary, the part consumption of the geothermal into the production for heat will be or should be at least 25% for Switzerland with regard to the need of heat to 2050. So what, as I said, it's a quite aggressive program, and we need really now to move forward. We need to reduce permit durations or time to get the authorization, also time to make the well planification and the well operations. And to do that, we have a system in Switzerland of financial support by the Swiss Federal Office of Energy. We started since 5 years, and this kind of supports our two kind of projects, the heat one and the electricity one. And you have support both for the exploration steps and then for the, let's say, when the valorization, the drilling operation steps. So it's a bit complex, but it works well, and you can get financial support up to 60% of your total cost of your project, so which is really important. So to give you an idea, currently, I try to make a summary, but we can say that we have with the Geothermal existing project already 50 million of Swiss francs even to support some heat production project, especially in terms of exploration steps, and almost 100 million for electricity production project, which has been granted. This kind of financial support is still active, I hope, for the next 5 and 10 years, which is really important to unlock some project with regard to the operators. Sometimes they hesitate, to engage the project with regard to the duration of the project and the cost as well. This is a most up-to-date map, just to give you the location and where our project, and also to give you the understanding of how it has been developed since the last 10 years. So here, it's a geological map. Of course, I'm a geologist as background, so sorry, I will give you some geological hints. But you can see here our country, and we are a smaller country. We are between the Alps mountain and the Jura mountains, and this is clearly the limitation also where we can develop geothermal. It's mostly along the Mola spacing, this geological basin, where you will find the geothermal resources. Why? Simply because here it's our water castle, which fill our reservoir located along this trend. So before 2010, we had very few geothermal projects. We had this famous one in Basel at the end of the Rheingraben, testing a specific project for electricity, unfortunately with some earthquake issue at the end. And then we had some geothermal bath project and swimming pool project here in the Yverdon area. And we had in 1983 first test of a geothermal well in Geneva. Since that, we started to have more projects between 2010 and 2020, located in Geneva. It's a big geothermal project at the scale of the canton, on the shoreline of the Lake Léman, close to Nyon, just west to Lausanne, and some in the northeastern part of Switzerland. And it was quite during these steps, and it's only since 2020 that really all the projects started due to this financial support solution we have seen from the Swiss Federal Energy, and by the fact that we started to get some results from first reservoir in mid-deep area. And that's the current step. So you can see between before 2020 and since 2020, we have a kind of boom of geothermal project. They are all now on the step of the exploration phase, and that's why I think it was interesting for this workshop today, because PIXIL is more about geophysics, use of geophysics, and we will need really now to invest and to improve the data quality and the understanding of our subsurface to unlock all these resources. So I will say that in the next 10 years, we will have a big development in the mid-deep project with a lot of investment in seismic acquisition. It's what we will see. So our approach, and also to give you some information of times, it's a quite basic let's say, approach, coming also from oil and gas industry, when we start always our project with a higher steps of data mining and exploration permit requests, authorizations. And once it's done, it's almost half a year to 1 year to get a permit. We start the scientific approach with with the valorization of all existing data, with the seismic reprocessing and the seismic acquisitions, the seismic interpretation, the reservoir modeling, until to get the final targets to be clear and to become confident and to enter into the well planification and the drilling operation steps. In this slide, maybe the summary is to say that actually it's already, let's say, an aggressive approach, fast one. It's between, yes, 10 to 4 years of times on the reservoir exploration steps, and between 2 and 3 years to the drilling operations. It's now the time we are looking for, but it's still quite long, I think so, especially about the exploration permit, and also some time for the authorization to make the seismic acquisitions, where it can take both 1 year. So it's, I think it's really to improve that, and it is a continuous discussion with the authorities, with the confederation as well, to make it better and faster. So I went to this slide just to discuss a little bit about the challenge, in fact, of our problematic with regard to the geophysics. Today, we are dealing with project where we are asking which kind of best kind of seismic acquisition to do. Are we talking about classical 2D survey where we are following some 2D lines, straight lines, or are we talking, or can we talking about what we call pseudo 3D, which is a really interesting approach currently, I would say, under development, where we have seen some project in Belgium with really nice results? Or should we really move forward with the strong and heavy one, classical 3D acquisition, like they done recently in autumn last year by the Service Industriel de Genève in the canton of Geneva? What is important here, and I wanted to open the discussion, is about the need to have such kind of workshop you are doing these 2 days to develop the innovation and to consider all the environmental constraints we can have in such project, the topographic constraint, and finally to find and to develop the best technical solutions to make faster and also maybe a bit cheaper geophysical acquisitions. We need also never forget to, as I said, the environmental constraint, like also the urban constraints, and of course the population, where the communication is so important in all these projects. So that will be our challenge for the next 5 years in Switzerland, especially our company, where we are involved in most of these geothermal projects, to conduct some seismic acquisitions, and we need just to follow and to find also partnership with the right person, with the right ID, and the good reflection for the improvement of our seismic campaign. So just to finish, in fact, also to give you the perspectives, in fact, what are we talking? Here it's a map with the existing seismic data set. So we had some few oil and gas exploration, mostly between the 90s. And now we enter into a new step where we can see with this different color, so it's all the French part of Switzerland, the existing permit granted. So you have the canton of Geneva with the operator, the Service Industriel of Geneva. You have a large regional permit with the society company INRIA, made of different, let's say, local energy operator for one. And you have different small exploration permit in the north of Lausanne, in the canton of Vaud, where you can see all these permits were granted since last year. So it shows you how it will be dynamic for the next years with the development of geothermal project, except this one, the light green, all are for heat project. This one is for electricity. And we have a big project in the pipe in the canton of Fribourg, quite similar to the canton of Geneva as well. It's ongoing, and a recent one close to the lake of Biel from the from the confederation directly where they need to find, let's say, heat production for some installation of the confederations. I indicated the amount of the project in terms of seismic acquisition, and you can see that the perspective is quite high. This project, the 40 kilometers has been acquired last year. This one also last year, just before Christmas. And now we enter into these steps to cover and to make real these seismic acquisitions. So we know that it will take some 2 years before to get the results and to enter into a more steps of drilling operation. So it's a dynamic period, very exciting, and really nice. We can unlock the potential in Switzerland. We hope that everything will be good without let's say, geological hazard issue, as we are in the pure exploration steps. And once all this work will be done, that's clear, we will enter into another step of more, let's say, production steps. So thank you. I will open.
Well, thank you, Jerôme. Thank you very much. I'm taking over because I'm not sure that Julien is on.
Yes, I succeeded in entering the room. So sorry, so I missed maybe the 10 first minutes, but what I saw was also very interesting. So to see what happened in Switzerland. So maybe you said it at the beginning, so I'm sorry if you did, but you were focused on Western Switzerland. Are you also, is the situation more or less the same in the other part of Switzerland, or is there a variation?
So it's more quiet to the German part. So the communication is less, but it's indeed today I can say that maybe the 80% of the project are on the French part of Switzerland, on the western part. Also maybe more because the resources or the geological configuration is a bit better for geothermal project. So it's a kind of part of the reason. And also on the German part, they had, the St. Gallen project with the earthquake issue. So even if it has been mentioned by, I think, Mr. Graff, that the communication with the population was really good, and they were still trusting the project. But it gives you a kind of colder approach to re-engage more exploration project in this part.
Yeah, that was also, so you answered my second question, because I was in Basel. I worked in Basel in, I think it was 2006, 2007. I don't know if it is this event that you mentioned, but I remember that there was some seismic activities at this moment. And I was wondering how this has been dealt in, how the government dealt with that in Switzerland.
The fact that we start this year 2 projects, real one with drilling operation. One is AJEP, it's the one in the crystalline basement. So it's also nice because it's this one picture of the type of reservoir, and the next one is in the pure carbonate reservoir. So it's both so critical, important project. If both are successful, I think it will open the door to the following.
Okay. So thank you. So sorry, I asked my question without asking if anyone had other question. So does anyone ask question for Jerôme?
So I have a question. So Jerôme, you presented what needs in terms of geophysics needs on seismic. Do you see some other needs in other domains of geophysics, like electrical investigation or magnetical things? I mean, do you see some potential for these methods?
We especially the canton of Geneva tested a lot of these other methods like gravimetry and electrical profiles. So if we are talking about electricity profiles, for shallow geothermal resources, yes, of course, it's really powerful. It is used a lot without any doubt. For mid-deep targets below 1,000 meters deep, it's not really useful. The result was really poor, and that's at least for the geological setting of the French part of Switzerland, the results. Yes.
Yeah, I suppose also that the urban conditions do not help, because there are plenty of networks already in place. And
yeah, we will never reach the quality, the resolution of what can be offered given by the seismic.
So for the time being, your geophysical needs are basically deep seismic for the imaging and microseismic at the development stage.
Yeah, correct.
So, thank you. Thank you. Other questions?
Yes, maybe.
Yes.
Go ahead. Thank you, Jerome. Just to pursue on the geophysical method, do you try some magnetotelluric acquisition in the first phase in order to know the very depth of your carbonates below the molasse?
We had one test in Geneva. I don't remember well here this result, but it's something I can investigate. I think it has been done by maybe the BCAM.
Probably,
so. Yeah. I think so.
Yeah. Because it's a very cheap method.
Yeah.
So before seismic, I think it's a good proxy.
Yeah. No, that's correct. But you know, some of our projects now it sometimes come too late, because sometimes the operator were already decided just to invest in, for example, large or small 3D, and on it's done, they say, okay, no, we just invest in the 3D and nothing else.
Yeah.
That's
sure. Magnetotelluric is just for a first phase of exploration.
Yeah.
Well, the thing as well is that they have a large database of vintage seismic.
Yes.
So currently, we are reprocessing that, and it provides already a good basement for the study.
Yeah. No, I went not into details, but for example, in the canton of Vaud, we are more than 200 all vintage seismic line that can be pre-processed, and we have the chance to work with the real-time seismics to do that job. So it's ongoing, and yes.
What about the 3D? It is a cable-less seismic.
Excuse me, can you repeat the question?
For the 3D acquisition, do you have cable-less acquisitions, or do you have a lot of cables?
Yeah.
No.
Well, sorry.
No, please, Jean-Claude.
Yeah, so if you refer, Marc, to the 3D in Geneva, yeah, they use nodal systems.
Yeah.
Okay.
Okay, so thank you. So I think there's no other question. So we planned a break until 10:40. So I propose that we make the break now. I will come back 3 minutes before, so that we can try to show to install the presentation of the next speaker. So thank you to all the speakers for this first part. So I think we had a lot of discussion, and it was really interesting. So I propose to see you in 10 minutes. Yeah. Thank you.
Okay. Thank you.
Thank you very much, Jerome. So maybe just a short introduction on the two next talks that you will see. So the first one will be given by Bruno Tourlière in collaboration with Mario Billa, and he will present a targeting tools called HexaCBA. And the idea is to show how this can be used in the Pyrenees for geothermal resources and lithium as byproduct. So we already talked about lithium in the previous talk. Then you will have a talk on the Club Saumur by Romain Billot. So originally we wanted to use these two talks as a basis for a round table, but it was a little bit complicated to organize it. So we forget about this idea, but however, we still kept the idea to ask all the participants, thanks to a survey that will be sent at the end of the workshop. So we wanted to ask you what you think about this, not the talk, but the tools that are presented here. So we would like to hear from you what you think about this targeting tool and the use of lithium as byproduct, and then also what you think about the organization of Club Saumur, if you think this can be a good way to have a common project on geothermal energy, if you think we can mimic this this organization. So you will receive at the end of the workshop, so maybe not just after, but in the day after the workshop, you will receive this survey. So if you can fill it, it will be very, very helpful for us. And so now I think I said enough. So maybe I can give the floor to Bruno. And so, as I said, he will present the tool HexaCBA. So Bruno, when you want.
Okay. Hello, everybody. I am Bruno Tourlière, and with my colleague Mario Billa, we made that presentation about the HexaCBA. First, we are retired geologists, and we are not formally part of that PIXIL project. But Pôle Avenia gave us the opportunity to present you the use of HexaCBA as a GIS-supported targeting tool and its application to geothermal resources in Pyrenees. First, what is HexaCBA? CBA is based on the CBA, and CBA, that means cell-based association, is an alternative to GIS-supported classical predictivity mapping methods that aims to a better exploitation of non-perfect cartographic data. And the HexaCBA is an extension of the concept of CBA. The first publication about CBA has been made in 2015. So what is the concept of CBA? CBA, the principle of the CBA is that the resolution is not the most important thing. What is important is the complexity of information that is more relevant for targeting at strategic scale. CBA combines a regular grid of cells and an attribute table that allows the replacement of the relation point polygon by a relation point complex environment, that is association, in each cell. That's the reason why it's cell-based association. In CBA, the coding of each attribute is binary. First, 1 if a parameter is present, or 0 if the parameter is absent in a cell. At that binary coding, real numerical values can be added if applicable, for example, for GEM or geochemistry or geophysics and so on. After that coding and after getting that attribute table, we apply on this relevant or different relevant numerical processings like classifications, ranking, multivariate statistics, and so on, just to characterize the associations contained in the cell to highlight the cells favorable for a specific phenomenon. What are the limits and the characteristics of the CBA? In principle, CBA involves a reduction of the resolution of the original data, but reduction is compensated by the consideration of a more complex environment contained in each cell. What is positive in CBA? So CBA can minimize the problem of location uncertainties. CBA is coupled to a numerical approach of the associations. CBA is able to distinguish different favorable environments and characterize them. Non-relevant formations can be eliminated from the calculations, for example, alluviums or superficial formations. And CBA allows the integration of all types of specialized data. But take care, size of the cells is a critical parameter. This is very important. Grid positioning can be a critical parameter. Irrelevant formations can affect the results. Grids and classifications are not transposable from one place to another place. But it is available for all the GIS treatment. Scale coherency is preferable. Next, to go from CBA to HexaCBA. Like CBA, HexaCBA is a procedure that allows the extraction of georeference data. You create a multivariate space is created by the superposition of a regular grid of hexagonal cells. That's the difference with the CBA that has square cells, and several layers of informations, vector or raster, that will become numerical or coded attribute values for each cell. The multivariate data set associated to each cell can be then treated by several numerical methods. Frequency calculations, statistical combinations, multivariate calculations, and so on. That data set is also compatible with artificial intelligence tools. The hexagonal shape of cells is biomimetic and more isotropic, that can minimize artifacts related to the square cells. And for that study, the hexagonal cells are of around 10 square kilometers. That is an area compatible with the size of hydrothermal cells. That size is also the optimal size for the realization of prospectivity map at strategic scale. How to build the HexaCBA dataset? Here we have the geological map of the Pyrenees and the zoom on that area with the geological, lithological coding. On that map, you apply your hexagonal grid, and you get all the, here in that case, the lithological parameters that are present in each hexagonal cell. For example, for that cell, oh, excuse me. For that cell, you have an occurrence of leucogranite, an occurrence of quartzite, of mica schist, and so on. So, if in that cell, here you have the table, you have the leucogranite here, the mica schist, the migmatite, and so on. So each formation is coded 1 if present in the cell, or 0 if absent in the cell. We don't care the specific area covered by the lithology is not taken in account in that process, because we estimate that if the formation is present, it's all right, because the geological map is only the intersection between the actual topography and the geology, and the specific area covered by the lithology now is not representative of the true volume of that lithology. So if it is present, it's 1. If it's absent, it's 0, even if the surface is very small. Another extraction. Here, this is the DEM coming from SRTM survey. and we are able for in each cell to get the mean altitude, the maximum altitude, the minimum altitude, and the difference between the lower and the higher altitude. So we get here not binary coding, but we have continuous data. So this is the mix between the two information. First, in that table, you have the numerical values and then the coded values, and that table will become our the data on which we will be working. We will be applying the numerical treatments. Data processing. Historically, when I say historically, it's a very short history, but okay. That was the first things I was doing in 2015. There are two main ways to process the data. The first way is to classify all the cells in the study area and to select the group that are related to cells containing the phenomenon. For example, occurrence of gold. If you are looking for gold, you make the classification on all the data set, and you extract only the cells that are in families. The families attributed to gold occurrences. And the other way is to use standard cells, so that are cells that are containing the gold, for example, and you generalize to the study area all the associations present in these standard cells. Several methods are applicable: exact signature, ranking by frequency, frequency ratio, and so on. In that study, the study about Pyrenees and lithium as geothermal events, in that study, we added a combination of multi-thematic attributes with a simulated calculation, Euclidean distance, using a kernel mixing ranking results for lithological association for lithium occurrence and outsprings, and its sources, density faults, and topographic parameters. So that is the conceptual model of that study. And that conceptual model has been created by Taillefer in 2017. To get the geothermal system, you need to have important age difference between infiltration and thermal springs. You need faulting as pathway for fluids, and you need specific geology, essentially radiogenic granite and gneiss that gives the heat to the fluids. We worked with public layers. So we have the geological map from the European ProMine project. We have a DEM from SRTM data. Geochemistry is coming from the geochemical survey of France made by BRGM. Radon data are coming from the ERSN maps, and geothermal springs are coming from different public sources. So the study itself, here you have an image of the 4 kilometers hexagonal grid applied to the ProMine geological map. This is now the base of our job. So as I already said, we have 4 complementary thematics that can be combined. First, the presence of lithium enrichment, what we call a mobilizable lithium. As there are not known occurrence of lithium in Pyrenees, cells with lithium greater than 200 ppm from geochemical samples has been considered as favorable. Secondary, the presence of geothermal reservoirs, medium to high temperature, indicated by thermomineral springs, that high temperatures are mainly produced by natural radioactivity in granitic massifs. 3, higher permeability related to fracturation, and 4, a higher difference in altitude, longer time of percolation of fluids in rocks. So these 5 parameters, lithium enrichment, geothermal reservoir related to hot springs, natural radioactivity in granitic massifs, high permeability, and high difference in altitude, all these 5 parameters will be combined to get the favorability map. So this is the best data. In blue crosses are the places where you have lithium higher than 200 ppm, and the purple stars are the location of the hot springs in the Pyrenees massif. So by using frequency ratio on lithological formations from using as reference cells the cells containing lithium more than 200 ppm, we get that map where all the orange, deep orange cells are the ones that are the most favorable environment, lithological environment for lithium enrichment. This is for geochemistry. We did exactly the same for the nos micros marchent plus, si? For hot springs, and you have in deep purple, in dark purple, the hexagons, the cells with the most favorable lithological environment for hot springs. So the complementary data, because we have already seen the lithium geochemical, the hot springs. Now we got here the map of the radiogenic zones coming from the IRSN radon mapping of France and extended to Spain, because we have the same formation on the both sides of the boundary. That gives you the heat production areas. Here you have the cells with high density fault zones. And here you have the cells with a higher difference in altitude. So we combine using a similitude approach, that is a Euclidean distance, taking into account that kernel. That means that you have a difference, difference of around 1,200 meters. You have a ranking of lithium in lithium, geochemical lithium of 19, a ranking in hot spring of 15, and so on. And once you combine that zones with mobilizable lithium, thermal zones, heat zones, and difference of altitude and faulting density, you get those purple hexagon that are the places the most favorable for having hot springs and probably lithium contained in the water. in conclusions, so HexaCBA is a procedure that allows the extraction of any set of georeference data as attributes of spatial entities that are, in that case, hexagonal cells in a regular grid. Specific numerical processing applied to the attributes of the cells will conduct to the creation of favorability maps. In that study, the combinations of attributes related to the lithological map, GEM, heat flow, and fracturation have been used for the targeting of favorable zones to the presence of lithium associated to active geothermal systems. As a generalization, HexaCBA associating a multivariate and multi-thematic attribute table to standardized spatial objects, the hexagons, can generate favorability maps in many fields of the earth sciences. And as a next step, it seems necessary to focus on the search for new processing tools adapted to different types of data, binary, real, coded, or why not, alphanumeric, and thematics to different types of data and thematics to improve the versatility of the procedure and the reliability of the results. Okay, thank you. Thanks for your attention.
Thank you very much, Bruno. So for me, it was really interesting to see this, and I thank you for the references that you gave at the end of the, the presentation. I will have a look at these references. So, do you have questions for Bruno?
Yes, I have.
Yes.
So, Bruno, what was the frame of this study? Or I did not really understand if you developed this tool, or you use this tool to run a study on the Pyrenees area. Can you tell us more about the context of this project?
Well, as I said, we are retired geologists, but we keep we are still I would say more or less operational, and we promote that tool. But it is a purely personal way. But Pôle Avenia gave us the opportunity to show you what we did on the Pyrenees Massif, just to show the capability of the method.
Okay, so was it run on some other areas of France and on some other for other topics like geothermal potential, for instance?
That tool has been essentially developed for mining purpose, for mining prospectivity. But okay, we extended for that study, we extended the concept to geothermal potential, just to show that the method is probably very versatile and can be used in many fields of the earth sciences. We have to say that that method has been developed in BRGM first, and is still in progress in BRGM, and but we promote it. We try to promote it for all the geologists, because we think it's a very interesting method.
Okay, so is it accessible? I mean, is it a commercial package? Or...
Absolutely. For the moment, there is no commercial package. It's only I did all that study has been done with QGIS and OpenOffice.
Okay.
You just need those two software to make that kind of treatment. It's very, there is nothing complicated in it. Okay. It's only a combination of standard functions of GIS and the calculation. Okay. So it's quite easy to use it. Even if it could be possible to automatize to make automatization of the process, because but for the moment it's made by hand, right?
Okay.
I have a question too. Johan from Realtimeseismic too. You said it's made by hand. I know the edge work that represent. How the definition of the size of cell is not a parameter that can be a problem if you have to change the cell. It's definitive. Not.
I'm not sure I understand the question, but the size of the cell is is important because it is important to have in the cell a complex environment, because we are trying to combine different parameters. So if the cell is too small, it becomes like a pixel, and you have only one information in the cell, so it's not very interesting. As I said, what is interesting in that method is that you have a complex information in each cell. Each cell is may have 15 or I don't know 100 parameters, and you can combine all those parameters in the cell. So for me, it's quite important to have a reasonable size for the cell to have a complex information in it. The other thing is that I think that method is more reliable for strategic at strategic scale. That means I don't know, 100,000 scale maps and so on. It's not really applicable for very small areas, because when you have a small area, you have many informations, and you don't need to have that very wide view of a huge area just to select the most favorable places. Is it clear?
Yeah, I understand. Yeah, the method is to manage a huge area.
Yes. Yes, it's for strategical approach.
Okay, thank you very much. So I'm sorry to interrupt now, because it is time that we move to the next talk. Maybe just before the closing, if you have other question, we can go back on this talk. And just before we go to the next talk, before the closing, we will try to make a picture of the conference. So just before the closing, I will ask you to put your camera on for those who want. Of course, it is not mandatory. Just trying to have a picture for the conference. So thank you very much, Bruno, for this talk and for the discussion after. So now it's time for the talk of Romain Millot, and he will present the club Saumur. Romain, are you here?
Yes.
So maybe Bruno, can you stop the screen sharing? Thank you. And Romain, can you try to share your screen?
Yes. Do you hear me well?
Yes.
Okay.
So I still have the same. So I still have the same problem of black screen. So I will reboot. So this is just a message to the administrator of the talk that maybe I will be out of the room for 2 minutes. But okay. So just before, yes, you can start whenever you want, and I just reboot my screen.
Okay. First of all, I would like to thank the organizers for inviting me to introduce the Club Saumur. It's a kind of French network aiming to valorize industrial and geothermal brine for their water content, for their dissolved minerals content, and also for their energy. So I would like to move on with the next slide. And let me introduce what are the main objectives of this Club Saumur. The main objective was to gather different industrial partners involving in very different sectors, water treatment, geothermal energy, oil and gas, and also chemistry. But all these industrial partners are interested for the valorization of the brine. Initially, we start with restricted numbers of members to guarantee to be efficient in terms of functioning and operating, but we aiming to gather different partners covering the whole value chain of this economic sector. This network of exchange is for sure aiming to generate new collaboration, new projects, and to collectively finance innovative actions that open up new business opportunities. And also, this is also a place to keep up with the latest scientific and technological innovations. So you have on the bottom of this slide the different logos of our first partners. The first project that came up from this network was the Nectar project, and it consists of a creation of a web services interface to simplify the access to the different databases on brine at the national scale of France. So this is a schematic idea of what is the project. I don't know if you can see my arrow. So it's initially started from the industrials partners. What are their needs in terms of valorization for their industrial or geothermal brines? What is the data implementation? And our duty at BCAM was to start to homogenize our different databases, either dealing with different thematic for the brines. And all this together was a web service interface to access the different databases in a simple way. What are the different benefits for this project? As I told you just before, it facilitates access to brine data on the national scope. So we initially thought it was a national initiative, but we are now thinking about international cooperation. It's also a customized and scalable interface that can allow you to deliver data with added value. And it's also a source of prospective information on substances that may become of interest in the future. We have a team at BCAM that we call a mineral intelligence team, combining economists and geologists. And this is the one of the added value of the BCAM in this network. And this Nectar project is also an interface with a private access, allowing you to have your own data and put this data in the global context of all the brine data at national scale. And the final objective is also business development, create new activities or activities related to the main activities of your company. Well, having said that, what are the data we are looking? So of course, this is chemical data for major and trace elements, but also the need to combine information about the aquifer and the surrounding aquifer entities in terms of permeability, porosity, geology, and water flow velocity. All these data gather very important, but also we have to deal with drilling information in terms of depth, diameter, well screen, pumping, test parameters, volume transmissivity, and so on. And last but not least, we are trying to combine all this data with radar, remote sensing, and geophysical data to have the most complete overview of what is on the ground in terms of brine. As I told you before, it's also a network to provide up-to-date scientific knowledge. And we have expertise on data quality, so that's the way to add value to the data. We are trying also to define the typology of the brines, what are the different hydrogeological contexts, what are the main processes or formation mechanisms that can constrain any variable substance. And also the final objective is to have a better knowledge of this resource, both in terms of water, but also dissolved minerals. And we're also trying to optimize sustainable management for both extraction processes, management of the extraction wells, energy valorization, but also about the water in terms of reinjection, dilution, and aquifer research. There's different action and opportunities at different levels in terms of funding opportunities at French national scale, INRIA, but also at the European scale with the EIT raw materials, the European Raw Material Alliance, the Horizon Europe Coal, but also many places for networking, like the Hydro-Géo Environnement today with this workshop, the European Lithium Institute, and the French Committee for Strategic Metals, the COMEX. Last but not least, there's also a very favorable context to promote this kind of network, because this objective of industrial production fitting the sustainable development goals of the United Nations. I mean, to produce local, sustainable, responsible, and also with low CO2 footprint. So, thank you very much for listening to me. And if you have any question, I will be very happy to answer. And if you have a question, maybe you can contact me either later. Thanks a lot.
Okay. Thank you, Romain, for the presentation. So, as I said, we will ask after that the participant to we will ask for their opinion to see if we can apply, for instance, the system, so the way of federating people to geothermy or to other topics. So we will let you know when the result of this survey, and maybe I think that people are free to contact you if they want more information.
Yeah, sure, definitely. Yeah.
Yes. Do you have questions for Romain?
I have one question.
Yes.
Thank you, Romain. I think it was an excellent idea and very interesting project. Do you plan to extend it to gases? Helium, hydrogen, CO2, which are present in so many brines?
Yeah, that's a very good question. Initially, we start focusing on dissolved minerals in brine because the main partners, industrial partners, are experts within having technologies for the direct extraction of mineral substances. But we have good contact with different operators for gas industry. It's probably a good way to expand the consortium and to gather more and more very interesting partners. Good question.
Thank you. Other questions? I have one question. So you show that you in Club Saumur there are mostly industrial. There's no academics.
No, because I mean it's the idea was to create business opportunities, and why we decided to take the lead of this initiative because we have all the databases of the different thematic. For water, for minerals, for geology, and so on. So we are trying to through this Nectar project, the first initiative, to gather and homogenize all these databases. But we have some regular basis meeting every 2 months, and we have external partners like universities or different experts giving a short talk about a new technology, a new initiative or a new project, just to make people aware of what is going on at the national level and what are the different calls, Horizon Europe, INRIA. So it's not a closed club, but we try to keep it small for the moment to be very efficient.
Okay, yeah, thank you very much. Other question? No, so if there are no other questions, so yes, there is a question on the chat. These databases are public or private?
Okay, yes, for most of them they are public. It's one of the duty of the BCAM activities to promote public data science, but for some of them they are not public. They are private, and also the data from our partners are private, and we are able to tag them and to use them in the general context of the world database.
Yes, that's interesting also for PIXIL, because at some point we plan to share some also some seismic data, and so this is something we have to take into account. And are there, what is the duration of this data? Are you able to guarantee that you can provide them for a long time, or?
Yeah, the initial thought was to have this 4 years activity and to be able to get a privileged access to our partners, and then we will make all the data public.
Okay, thank you very much, Romain. So
thanks.
I saw something in the chat. Is there no, nothing in the chat. Thank you very much. So I think we can move to the next talk of Marc Blaizot, who will present the industrial project Picasso. So I took the liberty, some liberty in the time slot. So we have around 15 minutes, 20 minutes. We are a little bit late, but since there is no round table, I think that we will still end at noon anyway. So sorry for the delay. Anyway. Marc, if can you share your slides? So for the moment, we have we see 4 slides. So maybe you can go. Yes.
I'm coming.
Yeah. And last questions. Can you put it full screen?
Yes.
Thank you. Yes, it's perfect.
You should have it full screen now.
Yes, it is. Thank you.
Okay, so thank you, Julien, for the invitation. I'm Marc Blaizot. I'm not dealing at all with geothermal, so maybe it's strange to see me today, but as Avenia and PIXIL asked me to present a cross-border project between Spain and France, I think that could be interesting also for some of you. First of all, Picasso, what is it? It is a CCUS project, so where it stands off for Pyrenees carbon abolition through sustainable sequestration operations, meaning trying to catch CO2 in the big plants in both northern Spain and southwest France, and then to try to transport it through the present gas network or through a new gas network that is in studying, and then to develop first the CO2 utilization and the geological storage mainly within the huge depleted gas fields we have in the Pyrenees Piedmont, Pyrenees foothills, in the French part. The project as a whole is to favor decarbonation and to go to climate neutrality. We hope to be able to catch, transport, use or store around 1 million tons a year at the 2030 horizon. Our Picasso is born. So I call this slide Picasso before Picasso, because clearly this CCUS project is in the pipe since 2 years, more or less, and was not named Picasso at its very beginning. For me, Picasso is clearly a child of COVID-19 because at the beginning of the lockdown, beginning of 2020, we have a lot of problem with different partnership of Avenia. These companies, whatever their size, very big major company or very small startup, got big problems. Everything was stopped, and the oil and gas domain worldwide was extremely affected by this lockdown everywhere from China to the US. It's more than 100,000 people which were fired everywhere in the world in this domain. And we were wondering whether this was conjunctural just because of the COVID, or if it was more a structural long-term problem, this decrease of activities. And the answer from a lot of Avenia partners was it's not conjunctural, it's more long-term problem because of disengagement, both from citizenship and from banks and finance, to avoid fossil energies. Second answer was more optimistic. We have a lot of skills in oil and gas domain, mainly geoscience and drilling, which could be applied in a more sustainable manner, meaning towards carbon neutrality. And one of these domains is clearly the underground storage. We know how to produce gases. We could know how to inject gases. And for that, we need also clearly to capture and to transport, meaning to be all along the chain. So it's give birth to a new leash for the emission in France. And we were also relying on a first and successful demonstration pilot made by Total in between 2011 and 2013, the Lac Rousse pilot, where we were able to inject more than 50,000 tons of CO2 at that time in a former depleted gas field at around 4,000 meters deep. So the pregnancy on this project, starting April 2020, we start with the first emitters mapping in the southwest of France, New Aquitaine and Occitania, and we remark and map 15 major emitters with more than 50,000 tons a year of CO2 going to the atmosphere, and with 3 main clusters, one southwest Toulouse in Comminges, one around the Post City in the middle of the map, and one northwestwards towards the land and towards Bordeaux. We map also the geological storage. You have there here in purple, and you see that we have a lot of them between Arcachon to the north and Saint-Gaudens to the southeast. We did internally in Avenia the first calculation for this geological storage and derive an impressive figure of more than 600 million ton capacity for CO2, which means more than 100 years of the Southwest France emissions. So we try to discuss with political authorities here around Pau, with the community of the Pau agglomeration and the Béarn region, and they show a strong political support to our initiative for developing a more integrated project aimed to decrease CO2 emission, because they have also the goal to become very quickly a neutral territory in terms of CO2 emissions in 2040, meaning 10 years before France or before Spain. For that, we need to check several points, and they ask us to look at the gas pipe network to see if it was possible to transport CO2, and to see and to contact all the emitters, so to look for their emission in details. So we take the leadership in Avenia to that, and we finally have a conclusion that we have a lot of storage capacity in France, but we have not so much emission. It was around 5 million tons a year and capacity of 600 million tons. So clearly we consider that Spain was also a very good candidate, even the key candidate for an integrated project in which emission and storage could be a better balance. So the key was clearly the access to CO2 and the access to CO2 in Spain. So we extend the mapping, and we try to look first at the Euskadi territory in northern Spain, because we know it's a very industrial country, much more than France, and we expect more CO2 emission. And it was the case when we look at the Ministry of Environment in Madrid. We see that emission in Euskadi, a very small country, was 7 million tons a year. So much more than in the big Southwest France region. Conclusion was storage are in France, but emission are in Spain. And interconnection are present between France and Spain, mainly two main gas pipe through the Basque Country and through the Béarn Mountains. And third, the lac Mayon, the poor area, is the very center of the emissions. So every emission is more or less around 200, 250 kilometers at the maximum from the lac complex, which could be a hub storage and a hub for utilization also. So you see there the first name of the Picasso project. We call it the LAC project for long-term answer to carbon quitting. Finally, we have a Picasso name at the end of 2020, because we integrate also a new Spain region, the Navarra, and it is finally a 13 million ton year emission in both France and Spain. So this CCUS project become more Spanish than French, and thanks to the Spanish emissions. So we want to change the name and to have a more Spanish name. So the Picasso name came, and because the P of Picasso could be a stand for Pyrenees, and so it's giving the name for this cross-border CO2 abatement project. We did then the first meeting with Spanish regions and emissions and emitters. And first we work with what we call a CTP, which is a Communauté de Travail des Pyrénées. So 6 regions which are together, plus Andorra, to work together all the Pyrenean questions. And this first meeting has been very good because CTP know everybody in all these regions, whatever they are in France or in Spain or even Andorra. So thanks to them and other political body, we were able to contact first Repsol in Madrid. Why Repsol? Because it is the most important emitter in Spain with Bilbao refinery, more than 2 million tons alone a year of emission. So one of the most important in Europe. And very strangely for me, we had the first meeting with them beginning of February, and already 2 months after, they joined Picasso project. So really important pace for us, because you know Repsol is a major oil and gas producer, a major company worldwide, and thanks to them, the project was clearly becoming a cross-border project. And we have been also able with important and very involved, I must admit, correspondence in Spain. I show you here the list in Euskadi, Navarra, and now also Aragon, a new Spanish province, which will maybe join Picasso also, to be able to start discussion with industrial emitters. We have the first meeting with Spanish emitter end of last year in Pau, and then in Pamplona. And we have been also very impressed because it works. The Spanish partners are very interested. And then we have even extended more than France and Spain to Italy now with SNAM, which is one of the most important methane transport company in the world to be involved in the project. So maybe in a more long term, we could have also gas, CO2 coming from Italy. We have other links between Spain and France through the possible synergy between the new hydrogen economy and the CO2 Picasso project. Because in Picasso project, we'll need hydrogen too. First of all, because we would like to pass all the boilers and burners of the old industry to oxy-combustion burning in order to get much more CO2 content in the industrial smokes in the plants, which could be like that easier to capture. And second, we like clearly to use CO2 in combination with hydrogen to generate through methanation, methanes, methanol, or e-fuels. So important links through this synergy with hydrogen, because as you may know, Spain will clearly be the country in Europe where green H2, green hydrogen will be produced first, because these hydrogen projects through electrolysis are generally combined with solar electricity, and South Spain is the key candidate for such. So on this slide, you see all the partners having already signed and joined the Picasso coalitions. So we have more than 20 partners. I think we'll be 30 partners in the coming weeks. So it's a real improving and encouraging support for us in Avenia to have all these partners, mainly French and Spanish, with us. So just to conclude, maybe I think also for PIXIL initiative, don't hesitate to get married between French and Spanish. It fits. Thank you.
Thank you, Marc.
So I have a question.
Yes, please.
So what's the cost of the marriage, of the wedding?
For whom?
Well, for companies like ours, for instance.
Well, how can I call that? The price. The price for entering Picasso is linked to the size of the company, meaning Repsol is paying much more than a small startup. You need to be member of Avenia first in order to become a Picasso member. So you have to pay the fee to Avenia. So it's between, for a small company, 300 euros a year. And for big ones like Repsol, I don't know exactly, but 10,000. I don't know if it's the question.
Yes, it is. Yes. Well, basically the question was, is it free to join the club, or do we have to pay?
It's not free, but it's very small amount of money.
Understood.
If you are small, if you are, I don't know, Aramco, it's not the same price.
Understood.
Thank you. Other questions?
Yes, Emmanuel speaking.
Well, thank you, Marc, for the presentation of the of this similar approach as the PIXIL as a transborder project or initiative. I wanted to have your point of view on the overall experience. Like we understood from your talk that there is a great interest in the technical aspect, economical aspect, and etc. But I wanted to have your view on the impact of the difference between the political approach from two countries, like not only the cultural approach, but also the legal framework. The question being, do you feel that is a real slowdown maker, or the fact that we are working together will move forward on the European aspect, for example, or because it's a larger scale, then there's a stronger push, or on the contrary, it's something that is more complex because it's two countries and two governments?
Thank you for the question, Emmanuel. First of all, with the discussion we have in Brussels with European authorities, clearly for them it's much better to be together, French and Spanish, and if we can even add other industrials from other countries, that will be very well received. Is it so? Also for the finance, for the aspect, I think it will be easier to be together. For the social and societal acceptability, let's say, I think it's also better to be to have a lot of projects. So for the time being in France, we have, let's say, 5 CCS or CCUS projects from Dunkirk, north of France, to Picasso, southwest, and I'm pretty sure that's better also to have several projects in the same time than to be alone. And the French government has been, for the time being, supporting the French-Spanish initiative, and the discussion about CO2 cross-border transportation has been started at the high political level between France and Spain, for example, because that is a question. For the time being, we can't move the CO2 from Spain to France or from France to Spain. We have not authorization for such. That's the case for other countries in Europe also. If you want to send CO2 from France to Norway, you have to cross several national borders, and today that's not possible. So that will be on the agenda of next month. You know, when France is leading Europe for 6 months, and that is in the agenda of a political discussion.
Okay, thanks. I'm quite convinced by what you're saying as well, that maybe sometime when we are alone, you know what I'm saying, when we are alone, sometimes we go faster, but together we go further. And
exactly.
And I'm quite happy that you shared your point of view with the PIXIL members, and so thank you for that.
Okay, thank you, Marc. Thank you, Emmanuel. So I think we need to stop the discussion now, because we need to go to the next presentation. But even if, as you said, it was not on geothermy, I think that there are a lot of common on the objective, and maybe of some tools that we use. So for us, it was also very interesting to have you. So thank you very much, Marc. And now the last talk of this workshop is from Jean-Louis Valls. Jean-Louis, can you share your slides?
Sure.
Thank you.
Thank you. Thank you very much for.
Yeah. Can you just try to make it full screen?
It is in full screen in my screen. Oh. No.
No, not for us, but if we can see them, so it's not.
Okay. Wait.
It's not an issue. It's just that it is smaller than it was, but we can see everything. So I think it's okay.
Wait a minute. I will try again.
Hmm?
It's always on.
Yes.
Okay. So
don't worry. It's okay. Yeah.
I'm sorry, yeah, but
it's okay. It's okay. We can do it like this. Yes.
Okay. So good morning. Buenos días et bonjour. I have divided my presentation in two parts. The first part in English and the second part in Spanish. And I would like to talk about cooperation, no? And before starting, and I would like to talk about the working community of Pyrenees. As Marc said just before, as a CTP community, Communauté de Travail des Pyrénées in French, Comunidad de Trabajo de los Pirineos en Español. No? This institution exists since 1983 and deal with cross-border cooperations between France, Spain, and Andorra. Just for the record, and in the timeline, 1983 is 3 years before before Spain joined the European Economic Community (CEE), as before the European Union, and 7 years before the creation of the first Interreg program. So I mean that CTP was really pioneer on the cross-border cooperation. And it is a managing authority of the cross-border program Spain, France, Andorra, better known under the attractive name of POCTEFA, which PIXIL is one of the programming project. And just to say that CTP has created in 2010, the observatory, the Pyrenees Climate Change Observatory, the OPCC, and we are currently preparing the Pyrenean strategy of climate change. So Pyrenees is that between is a natural cross border between France, Spain, and Andorra, and I would like to share with you some great images to dream about the Pyrenees. And this one. And so the Pyrenees borders is the longest French border. It's around 600 kilometers. And the area is 150,000 square meters.
So sorry to interrupt you, but we don't see the slides moving.
I know.
Yes.
Okay, so sorry.
Yes, it is frozen actually.
It is frozen. So, thank you. It is frozen.
It's okay. Yeah, it's okay.
It's okay. Yeah, it's okay now.
It's okay now. So.
Okay. So as I said, 150,000 square meters as superficie, and 15 million inhabitants. It's more or less 10% of the European border population. Do you see the new slide or not? It's frozen.
We are still on the one that showed the map. Yeah, it's not progressing.
And now?
Yeah. Okay.
Yes.
Okay. So just to a quick review on history. The Treaty of the Pyrenees in 1659, in the middle of the 17th century, is more or less established the border we know today. However, not everything is as clear-cut as a drawing of a straight line. For example, we have a French enclave in the Spanish territory called Quint Country, or Quintoa in Basque, or Quinto Real in Spanish. Is a territory located in the Pyrenees Atlantic department, in the Basque Country, and belonging to Spain, but administered by France. I mean that in this territory, eight French families live in the Spanish land, and the hybrid status is the same as before in the 17th century. I mean, the French post office provide mail delivery. The Spanish company, the electricity Spanish company, providing electricity, and the Spanish Guardia Civil providing security. So we are on the west, but in the east we have the same. But this time, the Spanish enclave on the French territory, with a village called Livia, because this during the Treaty of Pyrenees, this Livia was not considered as village but as a city, because there was a wall, a fortified wall around the city. So we have this kind of particularity in the Pyrenees, but it's really interesting. Now about cooperation and the Interreg program. So Interreg program exists since the 90s, and we are currently on the fifth generation of this kind of program. Now with 10 billions of euros for this kind of cooperation program. And you see on the screen that we have 60 cross-border program with internal borders, terrestrial and maritime borders, with 6 billions. So I mean that is the most important part of the budget, cooperation budget of the European Union, which we're in this kind of program. We have included the POCTEFA, but we have other kind of programs as a transnational. So it's no border. It's a space, geographic space area. For example, the Mediterranean, Atlantic, this kind of program. So now, with the authorization of the translator, I will do follow my presentation in Spanish, because my Spanish is better than my English. And lo que os quería contar ahora son las historias, ¿no?, transfronterizas. Pocas personas saben que la Unión Europea financia proyectos de cooperación transfronteriza, porque no sabemos no sabemos contar las historias de los proyectos y destacar los resultados. El primero que quiero contar es el proyecto del Hospital Transfronterizo de Cerdaña, HTC. Estamos a 4 kilómetros de la frontera francesa y bueno, después del Tratado de los Pyrenees hay dos ciudades, ¿no?, que se han cortado en dos, uno al lado español que se llama Puigcerdà y la otra en el lado francés que se llama Bourg-Madame. Antes del tratado estaban solo una única ciudad, pero en los años 90 en las dos ciudades existen dos pequeños hospitales, pero muy ancianos y que tenían que renovarse. Y se habló, en los años 90, se habló de por qué hacer dos renovaciones y no construir un hospital más grande, nuevo y moderno, ¿no? Durante 15 años se habló de estas posibilidades entre Francia y España. En 2005 se firmó el acuerdo entre Francia y España y el hospital se abrió en 2014, al final de los 2014. Ese es un resultado, ¿no? Es el único hospital transfronterizo que existe en Europa. Entonces, hay 250 personas que trabajan en ese hospital y son todas esas personas, todo el personal medical y administrativo es personal bilingüe. Entonces, aquí se favorece el tratamiento de los pacientes franceses que cruzan la frontera para seguir el tratamiento medical en el lado español. Es muy importante porque después veremos un poco lo que propone la Comisión Europea dentro de un horizonte 2050. Pero no es solamente construir un hospital, un edificio, ¿no? Existen los obstáculos administrativos y legales. Y eso es el uno. Aquí veis en la foto, estamos en la zona de emergencias del hospital, ¿no? Al fondo tenéis la ambulancia de la SEM catalana, porque en España la salud es una competencia de las comunidades autónomas. Y al primer plano veis la ambulancia del SEMU 66, del departamento 66, de los Pyrenees orientales, porque la salud es una competencia del Estado. Y la pregunta es, ¿qué ocurre cuando una ambulancia de emergencia francesa es el vehículo de emergencia más cercano a un herido en un territorio español? Porque el hospital tiene esas dos ambulancias. Entonces, no pasa nada. No pasa nada. La ambulancia francesa no puede moverse porque no tiene el médico de emergencia colegiado en el colegiado de médicos de la provincia de Girona, donde está el hospital. Es decir, que esto es un obstáculo. Entonces, el trabajo nuestro es también resolver ese tipo de obstáculo. Después de 18 meses de negociaciones, se firmó un convenio entre los ministerios de la salud francés con les agences regionales de la santé y con las diferentes comunidades autónomas, con las instituciones sanitarias, justamente para resolver ese tipo de obstáculos. Solamente para daros una idea, es que podemos enviar médicos cuando hay una catástrofe en Haití o otros países, y aquí no se pide nada de saber si el médico está colegiado o no, pero entre las fronteras no es posible. Entonces, veis un poco la cooperación transfronteriza es también esto, resolver los obstáculos jurídicos y legales. Quiero pasar rápidamente también en otro proyecto. Ese proyecto, Recurut, es un proyecto histórico, ¿no? Aquí veis una foto. Estamos en la frontera donde estaba hablando antes, entre Puigcerdà y Bourg-Madame. Aquí la foto está tomada desde Bourg-Madame, ¿no? Se ve el puente donde es la frontera, donde pasa abajo el Segre, el río Segre, y al fondo el pueblo de, bueno, la ciudad de Puigcerdà. Es decir, que los Pirineos siempre han sido también territorio, pasaje, ¿no? de refugiados durante la Guerra Civil, durante la Segunda Guerra Mundial, etc. Entonces, ese proyecto ha valorizado, ha renovado esas rutas para justamente dar también una perspectiva histórica. Y también todo esto es lo bonito del Pirineo, es decir, que tenemos una historia común entre Francia y España que no hay que olvidar, que hay que poner en evidencia. Es decir, también queríamos enseñaros esa foto porque 70 años después de esa foto, en el mismo lugar, se construyó el hospital que acabamos de ver. Entonces, es decir que, bueno, estamos en una fase realmente bueno, muy interesante de cooperación. Otro proyecto entre PIR, porque bueno, el turismo también es el importante, ¿no? en los Pirineos para nuestros territorios, es el primer recurso que tenemos. Y entre PIR también un proyecto donde la idea era de crear una herramienta online para reservar en los refugios de alta montaña. Y esto también para daros una idea de cómo se puede evolucionar un proyecto. La primera fase se hizo en la programación 2007-2013 con un proyecto de proximidad entre los refugios de Aragón y los refugios de Pyrénées Atlantique. Después, en la fase 2014-2020, se hizo, bueno, eso era la primera fase, y después se hizo de manera transversal en el periodo 2014-2020 con ahora 70 refugios conectados. Es decir, que podéis vosotros, si os gusta la montaña, el monte, ir de hacer vuestra propia ruta a través de esa página web, y antes había que llamar al guardia del refugio para reservar una plaza, ¿no? Ahora se hace online. Eso también acerca, ¿no? Internacionaliza todo el turismo, todos los Pirineos a través de ese tipo de cosas. Y entonces pasamos de un proyecto de proximidad en una primera fase y en una segunda fase toda la parte transversal para añadir, quedan 30 refugios a conectar dentro de ese proyecto, pero estamos en una fase interesante. Otro proyecto también rápidamente, el proyecto Canfranneus. Aquí veis la foto de la estación internacional de Canfranc. Canfranc es un pueblo que está a 8 kilómetros de la frontera después de Olorón. Y creo que es el primer proyecto internacional de cooperación internacional entre Francia y España. Hay que ver que se iniciaron las negociaciones entre Francia y España en 1878. Se inauguró esa estación en 1928. Entonces son cosas realmente muy interesantes, pero después de un accidente de tren en los años 70, se cerró esa estación. Hay que ver que en ese pueblo de Canfranc ahora vive 500 habitantes, pero en los años de funcionamiento de la estación vivían 2.000 personas, 1.000 franceses y 1.000 españoles. Ahora lo que el proyecto, bueno, se abrirá de nuevo la estación, pero eso hay que ver que el transporte transfronterizo en tren es competencia de los estados, pero había que involucrar a los estados y la Comisión Europea. Entonces, en una fase se hizo en primer lugar, la región Nouvelle-Aquitaine decidió con Aragón de hacer de abrir un trozo para demostrar la viabilidad de ese proyecto. Entonces, en 2016, financiado por el POCTEFA, se financió la apertura del tren del 25 kilómetros entre Vedús geólogo, para demostrar que todo podía ser realmente, renovando la antigua línea, podría ser totalmente viable. Y es el caso. En 2025, bueno, el plan es reabrir la estación. Ahora están construyendo en una parte de la estación, porque es tan enorme, un hotel de 5 estrellas de lujo con el grupo Barceló. Y es decir, que ese territorio cambiará totalmente con la apertura de la línea, con bueno, el turismo, etc. Entonces, son cosas que realmente hay que poner en evidencia como proyecto de cooperación. Otro proyecto, y acabaré con este, aquí veis una foto evidentemente, de un incendio forestal. Hay que ver que los 115.000 kilómetros cuadrados de la superficie de los Pirineos están cubiertos por bosque, 50% cubierto por bosque. Entonces, estamos realmente en es una reserva incomparable de la biodiversidad, pero sigue siendo muy frágil. Entonces, el objetivo de ese proyecto, ¿cuál era? En 1986 hubo un incendio muy grave, muy importante, en la zona del Pertus, que es el puesto de aduana, ¿no? al este de la frontera, y murieron 5 bomberos franceses y desaparecieron 16.000 hectáreas de bosque. La cosa es que los bomberos franceses eran los primeros a haber visto el fuego, pero no podían intervenir porque tenían que cruzar la frontera. Vemos otro tipo de obstáculo jurídico y administrativo que hay todavía en el siglo XX entre Francia y España. Entonces, ese proyecto tenía como objetivo no solamente de hacer un plan de emergencias común entre la zona de Cataluña del sur y del norte para evitar ese tipo de incendios, pero también trabajar en un convenio, acuerdo administrativo entre Francia y España para permitir a los bomberos de los dos países de cruzar la frontera hasta 25 kilómetros para evitar ese tipo para intervenir rápidamente y ayudar a sus colegas. Resultado, en 2012 el mismo tipo de incendio en las mismas condiciones climáticas. Gracias a ese plan se salvó 3.000 hectáreas. Es decir, bueno, ahora, porque ese plan no estaba todavía completo, estábamos a mitad de ese proyecto. Ahora se ha cubierto todo el territorio. Y la idea que tenemos es que de una manera transversal, como lo hemos visto con el proyecto Entrepil, lo pasamos a los otros territorios para tener, ¿por qué no?, una estrategia pireneica de protección civil. Eso será nuestro reto. Entonces, lo que decía antes, ¿no? Me preguntaron, cuando estuve en la Comisión Europea, hace 3 meses, me preguntaron cuál era el futuro de la cooperación transfronteriza en los Pirineos. De lo que, como la habéis visto, tenemos ese único hospital transfronterizo de Europa. Creo que tenemos que capitalizar en ese proyecto. Y os invito también, como proyecto PIXIL, lo hemos visto, ¿no? con también el Picasso, el proyecto de Marc. Son cosas, no hay que hacer acciones separadas. Realmente la capitalización para mí va a ser la palabra clave para el futuro. Reunir los proyectos de las mismas temáticas, protección civil, geothermia, etcétera, etcétera, para que realmente tener proyectos potentes, porque los futuros programas, ya estamos preparando el POCTEFA 2021-2027, van a ser mucho más estratégicos. Y realmente lo que vamos a pedir a los nuevos proyectos es ser más estratégicos, dar un valor añadido no solamente al territorio, pero si puede ser a todos los Pirineos. Y lo que vamos a trabajar, por eso lo decía antes, el futuro de la Comisión, la Comisión Europea ve el futuro como desarrollando todos los servicios públicos comunes, que sea salud, como lo hemos visto, como el transporte, como el hospital, pero también el transporte. Eso será realmente el futuro que tenemos que dar a los Pirineos. Hoy estamos un poco, los Pirineos, estamos un poco en segundo plano. Es decir, que siempre que se habla de montaña, en Bruselas, siempre se habla de los Alpes, de los Cárpatos, y pocas veces de los Pirineos. Nuestro trabajo justamente es hacer llegar los Pirineos realmente en primer plano con esos proyectos como el vuestro para demostrar que somos un territorio donde la cooperación es el corazón, el nervio del futuro de nuestro territorio. También decir que nuestra preocupación en los Pirineos, en la CTP, es poner en evidencia a los jóvenes. Hicimos un foro transpirenaico de la juventud en octubre de 2021 con jóvenes que venían de los 7 territorios, y es verdad que esos jóvenes son muy, muy, muy orgullosos de ser Pirineos. Entonces, creo que también es una cosa que tendremos que tener en cuenta en los futuros proyectos, asociar los jóvenes, los estudiantes, etcétera, a los diferentes proyectos de cooperación. Y así acabó la presentación. Lo siento mucho tener, he pasado creo de 1 minuto el tiempo, pero no sé si hay, if you have some questions o unas preguntas. Gracias.
Thank you very much, Jean-Louis, for this presentation. Do you have questions for Jean-Louis?
Maybe not a question on my side, a remark. So muchas gracias por la presentación, Jean-Louis. I would just to underscore the CTP role in Picasso. I think I spoke about, but I really want to thank you for all. And I think you have a very special role, which is very important for us to be able to make the links between France and Spain. And what is amazing, it works well. So, and very quickly. So thank you so much again. And I think a lot of compañeros today can take advantage of your presence to also increase their own projects.
Thank you, Marc. It's our job to put together and to create links between Spanish and French and other actors. So
yes. Thank you, Marc, and I think that indeed, yes, we can thank you for this. And so as you, this was also, so this PIXIL project was for us a good opportunity to make more connection between France and Spain. So from INRIA point of view, we already had contact with BCAM and BSC, but this has helped us to foster this collaboration. So, and we hope that we will be able to extend it in the future. Does someone want to add something? Okay, so thank you very much. So we are a little bit late, but I prefer that my closing is shorter and that we had more discussion on the talk before, because I think it was the most important to have all these presentations this morning. So before I close the meeting and I say a few words to thank the people who helped me, maybe we can try to make a picture of the event. So for those who accept to be part of the picture, would you accept to open your camera? Mireia, can you take the lead on this?
Yes.
Because yes,
I will wait 15 seconds. Let's see if more people want to join. Okay. Okay, I'll take the first picture. Save it. Another one just in case. Okay, great. Thank you very much.
Okay, so it's time to say a few words of conclusion. So I don't know if it is a final workshop of PIXIL or if there will be a last one in April.
It is. It is.
It is, yes. So
yeah.
So it's not a complete conclusion. I will simply conclude the workshop, and I will let Josep in April doing the proper closing. So really today it was a lot of various discussion, and we saw a lot of thematics, in particular the development of geothermy in our two countries and also in Switzerland. So it was also a good thing to see that. Then I hope that you appreciate the two talk on HexaCBA and on the Club Saumur. So I remind you that you will receive a survey in which you can say if these two topics could be of interest for you, and if you think we can use it, take advantage of this for the future of PIXIL. So please, if you can answer this survey. There should be also a question on the event organized by Pôle Avenia on the Geoenergy Days. I think it will be added to the survey. So if you are interested in this event, let us know so that we can contact you, or Pôle Avenia can contact you when we will have more information on the event. So the last thing I would like to say is to thank all the people who participated, to all the speakers, of course, also the interpreters. So thanks to Guillaume and every people that provide the French and the Spanish translation, and even the reverse one at the end. So thank you very much for your work. And finally, so I would like to thank Jean-Claude from RTS, Emmanuel, Jérôme, and Nicolas from Pôle Avenia for the organization from the French side. And from the Spanish side, of course, Mireia and Josep from the BSc, and Margarita and Paloma for Geoplat. So I hope I did not forget anybody. So does anyone want to add something before we close the workshop?
Julia, maybe a word about the presentation. So will they be accessible from somewhere?
So the PDF, we did not decide it yet. So first of all, I should ask all the speakers if they agree to do that. So we will send a message. I don't know, Mireia, if you did that for the other workshop. So what is?
Yes, we did, and now I was about to email you with this information. But yes, we will have the two videos of the event, one for the first day and the other for the second day. So we'll let you know soon via email.
So there will be the videos and also the PDF of the presentation. Or
yes, but we need the but we need to ask the speakers if they agree.
Of course, it's not mandatory. Yeah. So if you do not wish your presentation to be on the website, it won't be here. We will ask you individually if you agree to share your slide. Yes. Okay, so I think it's it's all from my side. So if no one wants to add something, I forgot to thank all the participants. So I thank the speaker, but thank you all of you to attend this workshop. And so we are looking forward meeting. So maybe in Barcelona you plan to have a physical meeting, Mireia?
We'll see.
We'll see. Yes, I know it's difficult.
The pandemic, yeah.
Yes. If it is
don't know
possible,
yet.
it will be nice, yes, to meet.
Yes, it would be very nice, actually. Yeah. Let's hope we can do it.
Yeah. Okay. So thanks to all of you, and have a nice weekend, and hope to see you in Barcelona. Yes.